Hello, everybody. Welcome to today's Energy and Clean Tech Showcase from Deep Tech Showcase. Today, we are just going to open up, have the panelists introduce themselves, and then we'll have companies pitch in three different sessions. Session one is from 1:20 to 2:10 Eastern, and then session two, 2:10 to 3:20. And then the final session will wrap things up, 3:20 to 4:30. Just to give a little bit of background about Deep Tech Showcase, the organization running this event, our vision is to bring deep tech to the market by leveraging the power of community. So we created an ecosystem for deep tech only. This ecosystem consists of startups, tech scouts from the government and industry, as well as investors. The startups, of course, are eager to connect to the latter two, and the tech scouts from the government and industry looking for interesting technologies that are out there to solve some of the challenges that they're facing, potential partners and potential future acquisitions. Investors are looking for deal flow. So, it's a pretty good community where each type of entity, whether it's a startup, a tech scout, or investor, can get something out of it. And to anchor our ecosystem, we have monthly showcases by industry theme. This month's event right now is on energy and clean tech, but we also have aerospace and defense. Last month we had IoT, edge, cloud, and cyber. Next month, Industry 4.0. And we run the gamut also for themes such as advanced materials, autonomous systems, and computing systems, among others. At these events, and you're about to see, the startups pitch to a panel and audience of tech scouts from the government and major corporations and investors. Also, we provide guided introductions for the companies we work with. So, as I said, tech scouts looking for interesting technologies to potentially partner, acquire, collaborate with in some way, or investors are looking for deal flow. So they want to find some specific technologies typically. They might say to us, hey, we're looking for, I don't know, energy tech or clean tech, just to pick a random example. And for companies that we're working with in those spaces, we send some profiles of the companies to review to those stakeholders. And if there's mutual interest, we create a warm introduction where business often follows. So this warm introduction, the stakeholder already knows a company's basic tech and they express interest in connecting with said company. So our upcoming showcases are Industry 4.0 showcase. That's April 25th. Industry 4.0 is, among other things, advanced manufacturing technologies, advanced logistics, advanced supply chain. So basically, the advancement of the process of creating or producing something and getting it to the end user. And then in May, on May 22nd, we have a microelectronics and semiconductors showcase. Semiconductors being something that's been really hot recently. Aside from the showcases and profile introductions, we also host Ask Me Anythings by some federal agencies. So we have one on April 4th with Naval X, the Naval X Northeast Tech Bridge Coordinator, where we will ask them questions about how companies can get involved with Naval X. That's part of the Navy. And we also do company webinars. So at this event, we have companies presenting as part of a group, but every now and then we have an event that the company is a star of the show. So just want to plug our upcoming company webinar with Blastwave, Preventing the Terminator, AI-resistant OT, cybersecurity simplified. That's on April 10th at 1 p.m. And we hope to see you there. Now, just a quick word from our sponsor, Eagle Point Funding. We have Mitch Gold here, who will talk a bit about what Eagle Point does and some of the grants ecosystem.
Awesome. Thank you so much, Brian. Just as he mentioned, my name is Mitch. I work here at Eagle Point Funding. We and Eagle Point and Deep Tech Showcase work together in kind of a complementary manner. What we do here at Eagle Point is to help all of the deep tech companies secure research and development funding with the federal government. So we know that a lot of times with Deep Tech Showcase, you're working on the connections, the networking, the accelerator, the necessary documentation even. So at Eagle Point, we will then help you with all of those applications. So we do a couple of things for you. The first one is we're going to pair you with the consultant who's going to identify, and navigate basically all the relevant opportunities for your company. So we want to be able to, we know, this type of funding is allocated to every federal agency out there. I know that we're here to talk about energy. It's one of my favorite industries. And we see these opportunities across the board, whether it's the Department of Energy, Environmental Protection Agency, or the DoD. So we're here to help you not only get funded from one area, but as many places as possible to finance your research and development and ultimately become an end user. And so the government can become an end user or customer of your technology. So the second thing we do there is once we've paired you with the necessary and relevant consultant, we're then going to actually help you. We're not only going to give you, we're not going to give you templates for you to fill in. We want to be able to help you with the majority of the work, actually helping you with that writing and help you tell the story of your technology to each agency because it needs to be told a little bit differently. So our specialty is not only streamlining, but taking that administrative burden off of you and applying to as many applications as possible so we can see the highest ROI for your company. My information is up here, so feel free if you want to ask me any questions, you want to book a call with me, anything like that. I am happy to answer anything or sit down with anyone here. I know that we're here to speak about energy, and as I mentioned, there are a lot of opportunities in that. And just a little more information, the way we work, we typically work in 1 hour weekly meetings. So if you do have any comments, questions, concerns, we're very open and transparent. We want to be able to have a nice flow of communication because that's the best way we see these applications continue to flow and streamline. But ultimately, that is what we do here at Eagle Point. Everything else is Deep Tech Showcase and how they help do that. So thank you, Brian. I appreciate the time.
Sure, thank you, Mitch. And be sure to drop your contact details in the chat to everyone rather than hosts and panelists, so someone can reach out if they want to learn more about Eagle Point funding. I highly recommend it. Booking a call with Mitch. So with that, we are going to go into our into the event. Let's see, I'm just hearing a bit of an echo, so I'm just going to mute everybody. Okay, so with our first session, we will have Glimpse present first, followed by Kind Designs, Clarity, Spinchy, and US Geometals. And in session 2, we're going to have Littoral Power, Margic, Falcon Green Energy, Undesert, Jewel Case, and POE Texas. And then finally in session 3, we have 247 Solar, Runwise, Rebuild Manufacturing, and Lion Energy. It's a great lineup. Here are the panelists for the first session, but it's actually better if we just collapse the screen and have the panelists introduce themselves on camera, on the big camera. So with that, I'm just going to go across my screen by panelists who I see first and have them introduce themselves. First, I see Richard Carlin. Richard, just talk a bit about yourself, your organization, tech you're interested in, and so on.
Sure. So I'm currently with the it's called NAVFAC Engineering Expeditionary Warfare Center. It's a warfare center for the Department of the Navy, focused on facility. So energy, water are very key areas. The dual use opportunity space is really when you think about from an installation standpoint, it's typically not going to be the far out kind of work. They're looking for things that are ready to go now. So if companies are developing that, we can opportunity maybe to prototype those, take prototypes and demonstrate it. Previously, I was with the Office of Naval Research for 25 years, and towards the end of that, I was in charge of setting up the innovation ecosystem, which included the Naval X, the Tech Bridges. Highly encourage you joining Lee on the Tech Bridge opportunity space there. So I can end it there. If anybody wants to reach out to me, I'm happy to talk separately.
Awesome. Thank you so much for joining us. Up next, we have Tito Colmenares.
Hey, Brian, thanks for having us as always. I am an independent investor. I worked in the battery industry as an R&D engineer developing next generation battery materials for a startup in Mountain View, California, in Silicon Valley. I work with other startups to connect them with a strong network of investors and talent all throughout the Bay Area and really the US, and sometimes help outsource talent from Latin America, which is where I'm originally from. So very passionate about energy and clean tech, an entrepreneur myself, so looking forward to hear from these companies.
Great. Thanks for joining us. Up next, we have Han Ko.
Hello, Han Ko here. Nice to meet you all. Actually, first of all, I want to say that it's always a pleasure and privileged to be here with the Deep Tech Showcase. You guys are doing a great job. Appreciate it. USACO Group is a company that I'm with. Actually, there is a /Midwest. I'm also serving as a faculty, but I'm here on behalf of USACO Group. I'm a founder and CEO of the company, and we're a venture capital company. What's unique about us is that we have a large portion of portfolio, including companies from overseas. So about 70% US and but 30% about overseas. So we do a lot of work with international platform, in other words. So in case those of you have interested in connecting overseas, please let us know. And also we have an office in California, Texas, and Midwest and New York area, but also have an office in Seoul, South Korea as well. I know a lot of today's topic is energy, so it's great. But Deep Tech Showcase always carries a lot of good topics, companies in defense industry. So I've been working with some of them before. So anyway, good luck to you, and hopefully we can connect on online or offline. Okay, thank you.
Great. Thanks so much, Han. Always a pleasure to have you join. And up next, we have Carolina Lewandowska.
Hi, hello everyone. So I'm Carolina. I am the partner at Starving Capital. So we're a VC fund based in London, UK. We are an early stage deep tech and tech heavy B2B hardware specialist fund that focuses predominantly on science-based startup with a high growth potential. We invest in the energy space and industrial sectors. We do exclude any biomaterials, pharma, and med tech that sit in the deep tech space as well. And personally, my background is in physics and engineering, and I spent the last 15 years working for the energy sector. So I'm very excited to be here today and to all the pitches.
Great. Excited to have you join today. Up next, we have Gerald Wang.
Yeah, hi everyone. So my name is Gerald Wang. So I'm from GC Ventures. So we are based in Boston, and we are the corporate venture of PTTGC. So that is a global petrochemical company with revenue about $20 billion US. And so our global headquarters is in Bangkok, Thailand. So as the CVC team, so our focus is on deep tech around material innovations, such as the sustainability, for example, carbon capture utilization, battery, new energy, biopolymers, as well as advanced materials like 3D printing, coating, composite for niche market like electronic devices and aerospace and etc. So today I'm here with my colleague Lisa Dufresne. So Lisa will be introducing her later. So yeah, I'm very excited to be here and look forward to the pitches.
Great. Excited to have you with us. Up next, we have Ariel Heyer.
Hello, Ariel Heyer here. I am an analyst with Clean Energy Ventures. We are an early stage climate tech investment firm, technology agnostic, as long as the technology can reduce greenhouse gas emissions by 2.5 gigatons by 2050. So very specific focus here. We invest in North America, Europe, and Israel, and typically do seed to Series A stage investments. So I'll drop our URL in the chat. Looking forward to participating in this panel.
Awesome. Thank you so much for joining us. Up next, we have Thomas Bloom.
Oh, I wasn't expecting this time. So unfortunately, I'm not going to be able to stay for the panel 3 that I was selected for. But I'm an active clean tech angel. I'm a member of Clean Energy Venture Group that Ariel just mentioned. And that's a pretty dynamic group that covers both, or there's 2 groups that work together. One is an angel group and the other is a venture capital fund. So the group is able to span pre-seed to probably Series B, Series C, where the fund is looking to do 3 to 5 and maybe more million, whereas the angels are doing your first 200 to maybe 400,000 as investors. And we, as you heard from Ariel, there's a preference for greenhouse gas reduction, but the angels are not bound by the commitments the fund has made to its limiteds. So we'll do water and sustainability, even if it's not a direct greenhouse gas reduction.
So thanks so much for joining. Happy to have you with us. Up next, we have Lisa Dufresne.
Lisa Dufresne, also from GC Ventures. Gerald did the hard work introducing us, so I'll just add, behind us is our portfolio of startups and funds. Most of them are in North America. But the other thing that we scout for is collaboration opportunities. So maybe later stage startups or even private companies that pitch today that may have a technology that either a GC is looking for, a petrochem refinery in Thailand, or one of our dozens of subsidiaries. I just wanted to add that. It's great to be here. I love Deep Tech Showcase. You know, want to be on these panels as often as I can. And I think Brian is bomb. So thank you.
Wow, thank you, Lisa, for that ringing endorsement. I could put that in my signature now. Brian is bomb. But up next, we have Javier Gomez.
Hi, everyone. Javier Gomez here from the National Security Innovation Network. I spend a good bit of my time here at the National Security Innovation Network interviewing startups and helping them find the many entry points across the Department of Defense. And excited to hear about the companies today and trying to figure out if there's any helpful advice or connections I can help make. Thanks for organizing this, Brian. Appreciate it.
Sure. Thank you so much for joining us. And up next, we have Ethan Kraus.
Hi, I'm Ethan Kraus from the Air Force's Office of Energy Assurance. So very excited to join the showcase and hear all the pitches. We're specifically interested in energy and installation energy resilience. So a lot of on-site generation and storage. Yeah, thank you.
Yeah, thanks for joining. And up next, we have Brent Kenny.
Hi, everyone. Senior Master Sergeant Brent Kenny. I'm currently stationed with the Air Force at Spangdahlem Air Force Base here in Germany. I'm super interested in a lot of like clean energy. What I want to do is find the technology and help integrate it into the Air Force to really just give us that capability to continue to operate in non-permissive environments. And so I've done this panel a couple of times and love these pitches. I found a few companies that I've been working with still to kind of help bring these capabilities to the Air Force. About to head to PACAF, actually. About to move to Japan in about 60 days. I just got an assignment, so looking forward to moving to Yokota Air Base and kind of taking on that region as well.
Awesome. Well, thank you so much for joining, Brent, and I hope that move goes smoothly. So with that, that is all the panel on here for now. I believe so. We're just going to dive into our presentations. And up first, we have a glimpse with Eric here to present. So Eric, whenever you're ready, you can share your screen.
Great. Thanks, Brian. Can everyone see my screen?
Yes, we can.
Awesome. So I have 5 minutes. Is that correct, Brian?
That's right.
All right, I'll go pretty quickly. Good to meet you, everyone. Thanks for the introduction. My name is Eric. I'm the CEO of Glimpse. Glimpse is a 1-year-old startup that we raised our Series Seed last year. We just released our product a few weeks ago, and I'm going to tell you a little more about what we do. And then if I have a few minutes left at the end, I'll give you a quick demo of our portal, which is a web app tool to review the data we produce for our customers. So very quickly introduction, we focused on lithium-ion battery cells quality. So the cells come typically in 3 form factors: cylindrical, pouch, and prismatic, from left to right at the top of that slide. These cells are integrated into battery packs, and then these packs typically are built into electric vehicles. They can also be integrated on the grid for grid storage, etc. So they're really the cells are the building blocks for sort of our energy storage systems out there. The problem that we're trying to solve at Glimpse is that typically you have a few hundred to a few thousands of those cells per electric vehicle, and it only takes 1 defective cell for a battery pack to fail. And so I'm sure you guys have heard some of those major headlines of fleet recalls or large fleet failures. And this is actually only the tip of the iceberg. Most of these failures are handled under the radar through field returns. So you're driving your car, you have an issue with your battery pack, and then you're asked to drive it to a service center and they'll swap your pack. This is a very costly event for the manufacturers. And our bottom-up analysis estimates that today this is about a $10 billion problem, and it's going to grow with the size of the industry. So with that in mind, we reviewed the entire space of battery quality control solutions. And here I'm listing all of the major inspection techniques to catch battery defects before they're actually built into cars. And I'm sort of classifying them along 5 metrics. So in our view, a good quality inspection for battery cells, a good quality inspection technique needs to be non-destructive. It needs to be scalable, so it needs to test the battery very quickly. In this case, we estimate that you need to be at least sub 10 seconds per cell. You need to be able to scan the entire cell, so not just portions of the cell, because a defect can be anywhere in the cell. It needs to be spatially resolved. So essentially, if you have a defect in the cell, you need to understand where it's coming from, what caused it in your manufacturing or in your gigafactory, and then how to fix it, right? And then your typical electrode layer is about 100 microns or 200 microns. And so we want to be below 50 microns so that we can detect defects at the electrode layers, which are the most common types of defects in batteries. So when you compare the entire suite of solutions out there, you realize that the best one, at least in our opinion, is called CT scanning or computed tomography scanning. And it's essentially the ability, it's like CAT scanning in the medical industry. It's the ability to produce a very high resolution map of the inside of an object, and in this case, a battery cell. In our view, finding a defect in a battery is a little bit like finding a stage 1 tumor in a human body. You're not going to be able to do it with a bunch of blood pressure or hardware test or EKG. You really need to look inside the human body and look for those latent defects that haven't materialized in terms of performance yet, but that will over the lifetime of the vehicle. The problem is that CT scanning or computed tomography scanning today is a lab instrument, right? So it's slow, it's local, and it's expensive. So it typically takes between 10 minutes and 2 hours to produce a full cell scan, a full scan of a battery cell. And then the data that it generates is incredibly heavy. So it's typically between 30 and 100 gigabytes per scan, so per battery, right? So imagine moving that data around. It's very complicated and very slow. And the fact that it's slow and local makes it very expensive. So today, CT scanning is a lab instrument. And what Glimpse is doing is actually we're turning this into a high throughput, low cost, and collaborative production tool, right? So we're working very hard on the speed. So we were able to achieve We went from 60 minutes to about 1 to 2 minutes for a full cell scan. We have a clear roadmap to achieving a few seconds by next year. And then we apply a layer of computer vision on top of those images so that we can extract the key quality features from those scans. We make it accessible. So I'm going to give you a quick demo, hopefully, if I have a minute left. But this is accessible from your web browser. You can consume that data as a customer and control the quality of your product across your organization. So there's no limit on the number of users that we allow on our platform. And then we have two products. We have the scan on demand and the on-premise scanning. I'll jump to that slide in a minute. One note is that we're mostly a software company. We actually partner with hardware vendors. So we have a partnership ongoing with Nikon Metrology. They produce the scanners, we'll help them design them. And then we layer on our software on top of it, and we turn their scanner from a lab instrument into a very scalable production tool. I'll move to our two product, and then I'll give you a quick demo. So two products, scan on demand and on-premise scanning. So on the left, scan on demand, we essentially have a scanner here in Boston, Massachusetts, and we perform scanning services. So customers send us their batteries, we scan them, and then we upload their data on what we call the Glimpse portal, which is this web-based portal. And then we send their cells back. So this is a smaller market, but this is a market that already exists today and that we're displacing. Typically, we're about 30x cheaper than whatever is available on the market today. And the customer experience is much better because you don't get your data back on hard drives. You get your data back on the web portal. The other business model is the higher scale one where we deploy our solution at the customers. So we don't have to ship batteries across the country. So our customers get the scanner, they operate it, and then we deploy our full solution on top of it. This is a much bigger market and much larger contracts.
1 minute warning, Eric.
Sorry?
1 minute warning.
1 minute, great. All right, so I'll give you a 1 minute demonstration of the Glimpse portal, which is a web-based viewer of the scan. So you're in demo mode here. You guys actually can sign up for free and access it. So we got some cylindrical cell, we got some pouch cells, some prismatic cells. I've loaded a couple scans to save some time. So this is a cylindrical cell. You can see here moving the cell up and down. You can see on the right where I'm looking on the left, and then similarly I'm rotating the cell on the right, and you can see it on the left. So these are very high resolution scans of battery cells. So this is a 18650 for those who are familiar. And then we apply a level of computer vision on top of it so we can extract key quality features such as overhang for those who are familiar with it. And then once we extract a lot of that data, so I'll give you another example here. We extract, core circularity and can thickness, etc. Then we plot that data into what is a quality monitoring dashboards. So you can check all of your quality features over time, and you can get sent alerts for outliers or concerning trends. You can perform preventative maintenance in your factory. How am I doing, Brian? Am I at time?
Yeah. I mean, if you're
great.
finishing up.
Sounds good. I'll send the link to this web app on the chat. You guys can, like I said, sign up. It takes 10 seconds. We don't use your email for marketing purposes. And you can explore all of that rich data set that we've published for free.
Great. So right now we have a question from Hanko.
Hey, Eric. Yeah, a great presentation, and above all, brilliant technology, actually. I think a lot of companies can use this stuff. Just a quick question here. Two quick questions here. First of all, how do you have your intellectual property guarded? And that's one question. Second question is, are you collaborating with any large companies, global companies on this technology?
Yeah, so maybe I'll answer your second question first. So when you say collaborating, do you mean with customers or partners?
Yeah, customers, or both ways, yeah. Yeah.
So we have a few paying customers, and then we're actually deploying our first on-premise scanning solution to our first customer. So this is a much larger dollar amount for our contract, and that's going to keep us busy for the next 2 or 3 months. And in terms of partners, yes, we partners with scanner vendors, so our hardware partners. We don't want to be a hardware company. but
Right.
we work very closely with them, and then they like us because we increase their sale level, right? Because we
Right.
turn their solution into much more for their customers.
Right. And your IP?
Oh yeah, sorry. Great. First question, IP. Essentially, when we deploy our solution to our customers, we deploy our software onto a computing unit, and we lock that computing unit, so no one has access to it. We don't have patent, or we just make sure that our software is very well protected. And we are not planning on filing any patent for our solution so far.
Okay. Where are you based out of?
Boston, Massachusetts.
Okay, got it. Right. Thank you.
Yep.
Yep.
Great. Lisa?
Hi, so again, Lisa Dufresne, GC Ventures. So I'm curious about what the driver is for someone to adopt. I mean, you would think it would be a natural idea that someone who makes batteries would want to make sure that their battery production is spot on. But do you also see that maybe companies buying those batteries, maybe car companies are going to say, once there's technology that allows somebody to do this kind of inspection, that they'll require it? So how do you see
Yeah.
the driver for the market?
Absolutely. Great question. Actually, the first large deployment that we're starting is actually with a buyer of batteries. So we have two types of customers, the people who produce the batteries and people who buy the batteries. I was sharing my screens because I thought I had the use cases listed, but I don't. They're on our website. But you have many use cases that we target, and some of them are more suited for battery producers, others are more suited for battery buyers. So typically, incoming quality control would be a use case for the buyer, right? Outgoing quality control would be a use case for the producer, right, etc.
Great. Tito?
Hey Eric, thanks for the presentation. So my question is regarding what failures mode are you missing with this method? I work in battery materials, so a little bit earlier in the supply chain. But I'm wondering, can you capture all of the failure modes with CT scanning, and why is it not being done more in the industry?
Yeah, so why it's not being done more? It's because it hasn't been scaled yet. And the reason why it hasn't been scaled is because no one has taken a comprehensive approach about how to scale it. And it's both a hardware and a software problem, right? So we're scaling it. Today, CT scanning is seen as a luxury for people who deal with batteries. They typically can afford, to spend 1 or 2 scans a day, or purchase 1 or 2 scans a day, or run their scanner so that they produce maybe 5 to 10 scans a day. What we're doing is we're taking that, we're increasing that by a couple of orders of magnitude. So it's not a luxury, it's kind of an essential technique for the industry. And essentially the defects that are currently escaping factories today, think of them as stage 1 tumors, like I mentioned, right? They're very hard to catch. If you use electrochemical based techniques such as cycling and storage, or formation, or OCVDK formation, which is one of the manufacturing steps for the production of batteries, these defects have no electrochemical signature, so they escape the current techniques. And the only way for you to find them before they turn into failure is actually to look through the cell and look for those defects everywhere. And I don't know if that's why you were asking, but those defects, typically they will turn into soft shorts. They create a bridge between your cathode and your anode, and that's going to drain your battery energy over time, and that's going to give your customer a terrible experience. And those can sometimes turn into fires or safety events.
Great.
Thank you.
So we're going to have Ariel and then Richard, and then we'll move on to our next company.
Thanks. So these are for lithium batteries. Are you chemistry agnostic? Would you be able to apply this technology to other battery chemistries, other different elements or electrolytes? How is this gonna grow if new technology comes on the market?
Yeah, absolutely. So one of our customers is a lithium metal battery maker. One of our customers is using gas-based electrolytes. So we're chemistry agnostic. There are different concerns in terms of defect for each chemistry, right? So you kind of have to look somewhere else in the cell depending on the chemistry, but that's where our battery expertise come from. So I'm from Tesla, spent 4 years at Tesla. My co-founder spent 4 years at Tesla as well. So we've seen a lot of those defects. We kind of know where to look in a battery as a function of chemistry. And yes, LFP, NMC, high nickel cathode, iron-based chemistries. We have customers that send us cells with different chemistries.
Great. Richard?
Yeah, I appreciate the presentation, Eric. Just two quick questions. One, I know you're early stage, so timing it's not going to be the speed you're going to eventually reach. But what is your turnaround time for the scan on demand? And are you open to a discussion where potentially Defense Department could provide a few cells to evaluate? If trying to contract months and months and years for initial
absolutely.
tests.
Yeah, absolutely. Scan on demand, the answer is very easy. We turn around scans within 24 to 48 hours. So we're much faster than anything else on the market. You send us 100 cells, you'll get your data back within 48 hours on the portal. We're super fast and super cheap. Like I said, we're about 30x cheaper than anything else. So we're sort of expanding that market, and we're making it available to a lot of customers for which CT scanning was a luxury before. For the on-premise scanning, which is a full deployment of our solution, that is typically between a few weeks to a few months. So this is a longer sort of deployment and sales cycle.
Right. Great. Thank you so much, Eric. That was
Yeah.
great. Please, if you'd like to leave your contact info or LinkedIn or whatever in the chat, so people could reach out to you if they'd like to discuss more, feel free. And
Sounds
with
good.
that, sure, thanks. And with that, we'll move on to our next presentation, which is Kind Designs. And we have Anya here to present that.
Hello, let me share my screen. Can you see my screen okay?
Yep. We got it.
All right, awesome. Nice to meet everybody. I'm Anya, founder of Kind Designs. We're a climate and construction tech startup based in Miami. I am originally not from here. I'm from Ukraine. I grew up in Israel, and I got the opportunity to come to this country when my dad got a job at the space program. So we're like a very typical Soviet family. My dad's a rocket scientist, and my mom was a gymnast. And so we came to the US, and like a good immigrant child, I eventually went to law school, which is how I ended up in Miami, where Kind Designs is based today. And I graduated, I was working in the US Attorney's Office, had a nice life. And then I started to notice that our city was literally sinking. And what I saw is that there's a lot of attention on this problem of rising sea levels, of storm surges, of flooding, but the narrative is very doom and gloom. Basically, enjoy Miami and coastal cities while you can, because we'll all be underwater by 2060. And so that didn't make sense to me. I started researching the space, and I learned that the first line of defense to rising sea levels and flooding has always been building seawalls. And the first seawall that we put in the water, pictured here in Galveston exactly 100 years ago, is almost exactly the same seawall that we're still putting in the water in a place like Miami today. Literally, there's never been innovation in this space. And the problem with these traditional seawalls, number one, is they're very expensive, and it's because of a very labor-intensive construction process. Number two, they destroy marine habitats. In fact, in the United States alone, we will destroy 50,000 miles of marine habitats by installing seawalls just by 2040. That's like driving Miami to Los Angeles and back 17 times. And so we started to think, how do we come up with a product that protects coastal cities from flooding, but is also something that's economical and something that's nurturing the underwater ecosystem? And so we came up with the idea of 3D printing living seawalls. And so the way that seawalls have historically been made, as you see here, is construction companies, they make their own seawall concrete slabs. So they make these molds, which take up tons of space in their yards. It takes 24 hours to create one mold and a big crew. And then you have to wait 3 to 4 weeks for it to cure before you can move the panels and install them. So it has to meet all the building codes, of course, and it destroys marine habitats because regular concrete leaches. And number two, because it's flat. So with a mold, you can't incorporate any kind of significant design elements. So because it's flat, all the sea life that live by the coast can't attach to the seawall, so it migrates. What we're doing looks a little different because we are 3D printing our seawall panels with a robotic arm. So we have the world's fastest concrete 3D printer. We print a 10 by 10 foot panel in 1 hour, and it cures in 1 day. So it can be installed within 24 hours of printing. Our panels meets the exact same building codes. We made it as traditional as possible so we can get in the water very quickly, which you'll see. So it's exactly the same strength, PSI, the same reinforcement, rebar placement. It can be installed exactly like a regular seawall panel, so same equipment and same teams. So structurally, it's identical, but because of the design capabilities of our robot, we can create a panel that also functions like a reef, that also sequesters carbon and collects data, and there's no additional cost. Our living seawalls are cheaper than conventional toxic concrete slabs. And so just to double click on the environmental benefits. So there's three main benefits. One is the marine habitat. So we are transforming a infrastructure, a seawall, into something that also functions like a marine habitat. And that's one, because of our materials. We have a proprietary mix that's non-toxic. It doesn't leach. There's no chloride. There's no metals. And number two, because of the design. On the macro level, the wet face of our seawalls biomimics mangrove roots. Because in Florida, where we're based now, mangroves are natural marine habitats. So we printed the roots into the face of the seawall, and the roots create caves where sea life can hide from predators. For sea life, safety is #1 priority. So if you have a space for them to hide, they will attach and thrive. And number two is the micro texture of our seawall is ideal for smaller organisms and corals. Number two is the carbon sequestration. By the way, the seawall pictured here on the left, this is only 4 weeks post-installation. The neighbor has a seawall that was installed in 1990, and it doesn't have this amount of growth. So in 4 weeks, this is doing better than a seawall that's been installed over 30 years ago. So the carbon sequestration happens naturally. It's kind of a bonus component of what we're doing. And that's because when sea life attaches, their skeletons sequester carbon naturally through biocalcification. So each panel almost becomes like a tree in that it sequesters 40 pounds of carbon per year. And finally, data. All of our seawalls have built-in sensors, and we're collecting 15 different water quality parameters. We can customize it to add other parameters. This is what our county collects now manually, so they already have budgets for this data. Instead, we can give them a login to our dashboard and they can see it live. And then we can perform some analytics, like predicting extreme weather events, algae blooms, so you can take mitigative action. Our business
1 minute
model.
warning on you.
Sure, business model is B2B. So all we do, we're a vendor. We print panels with some of the construction companies. They do the installation. And next, we're 2025, we switch to a licensing model so we can scale globally by providing the robots and the designs to contractors in all of those coastal cities. What's special, we have the fastest robot, concrete robot, the proprietary mix that I mentioned, and then the zero waste 3D printing process. And finally, the teams, myself and my CEO, Jeremy, comes from Icon, which 3D prints houses in Austin. And he was also employee #7 at The Boring Company. So he's a concrete expert and 3D printing expert. And then the final slide I want to share is that we've moved very quickly in July. You can see we're literally still sitting on these plastic buckets. Our employee #1 was hired in July. Then we got a seed, we raised a seed fund, $5.5 million, and had our first installation already in January. I'll show you the picture. And just last month, we already got our first government contract and won Fast Company's top 50 most innovative companies of the year. So here, just to finish with a video of the robot in action. So you can see it's very fast and completely autonomous. And this was the first installation. It's not done yet. They still need to do the cap. The contractor, our customers installing the product. And so what kind of designs are moving really fast because we're on a mission to replace every toxic seawall with an artificial reef, to make sure that every coastal city in this country is protected and that every at-risk city in the world is saved. Thank you so much.
All right, thank you. So we have our first question from Anko.
Yes, hey, great presentation and also a great solution. Awesome. Yeah, Jack, just two quick questions. Yeah, two quick questions. So could you tell us about the cost and the cost factor, versus other material? Also the durability with the seawater and weather, when you build a seawall?
So
yeah.
I'll start with durability. Our durability is identical to a traditional seawall. And that's because for starters, we're using the same rebar. The reason that seawalls fail is not because of concrete. Romans built concrete seawalls are still in the water, but building code mandates rebar. And when you use steel rebar, it after 10, 20 years, you know, it rusts, expands, and pops the seawall. So because we're using the same rebar, our seawall lasts exactly the same amount of time. We already have a way to reinforce our panels with no rebar instead of using fibers, which Jeremy was doing at the Boring Company with Elon. But we are not producing those panels yet because we want to keep them as traditional as possible just to get our panels in the water. So for now, it's 50 years. The second is the cost. We are printing ours already at $1,800 per panel, $18 per square foot, and selling them at 25 to 30. For a construction company to make their own, it costs them 25 to 30 to make flat panels.
I see. Right. Thank you. Appreciate it. Perhaps we can chat later. Thank you.
I'd love to.
All right. Someone in the chat actually asked what the carbon footprint of your 10 by 10 is, and are you able to use quote unquote green concrete in fabrication?
Yeah, so we are in a process of what makes our concrete more environmentally friendly is that it's mixed at a 30% lower temperature than Portland cement. And so that reduces, of course, the carbon footprint, and then it doesn't leach because there's no chloride and there's no metals. We're in a process of working with a company in Israel to look into incorporating recycling our waste, which is minimal, but back into the mix. So we're always open to more innovative solutions as long as it has to make economic sense.
Great. Also, we have a question from Richard.
Yeah, hi Anya, great presentation. I really like what you're working on there. Love 3D, and my facilities actually we work in green concrete. So one of the questions is, do you have any plans at this point to put something out in California? Only because we're looking at proximity to go see some of this stuff.
To see it, no. If we have 3 robots now, which has tripled our fleet. Two are on a track, so they print it continuously all day, and one is loose, so he can be shipped out. So if we get a project of scale, like right now we're talking to Bimini, it's like 5,000 linear feet, we will ship a robot. So we'll be in California as soon as there's appetite in the market, or if there is an opportunity for a joint venture. So partnering up with an existing marine construction company, and so they can have their own robot, our designs, and we give them tech support to print the panels themselves.
Great. Thank you. I'll definitely be in touch on this. Appreciate that.
Awesome. Thank you. Thank you, Richard.
Sure. And for our last question, we have Ariel.
Thanks. What is the sales cycle like for this? How long does it take for a seawall to get approved and allowed to be built in the first place?
Right. So this is the reason we're a vendor. We're a vendor to the construction companies. We don't want to do the installation. It takes, in Florida, depends what county you live in, between 6 months and 2 years to get a permit for a seawall. So we come in the very end. When a construction company already received the permit and they're 30 days out from construction, they place their order with us, and we produce the panels and deliver them to the site.
If I can, I just one quick question.
Sure.
Can you Can you produce the customized parts?
Yeah, right now we're working on a 2,400 linear foot seawall project, and they want to incorporate actually art into the wall because there's economic reason for it. In Miami, if you have a development over a certain size, you have to put 1.5% of it towards public art. So it's $1 billion development. It's $15 million budget. So they want the seawalls to count as the public art. So we can do incredible design things and still keep it living by creating the nooks and crannies for sea life to attach.
Right. Okay, great. Thank you. Appreciate it.
Awesome. Well, thank you so much, Anya.
Thank you.
Feel free to leave. Feel free to leave your contact info in the chat so people can reach out. And also, I think that some people had asked some questions in Q&A or in the chat, so feel free to answer those as well. And with that, we will move on to our next presentation, which is a Clarity. And we have John here to present.
Hey there, John Tracy. Good to be on board and be in on this pitch session. I will share and pull up my slides. All right, please let me know when this shows up for everybody.
You can see it.
Good, good. Okay, so Aclarity is a PFAS remediation company. It's actually, there are several categories of technology companies who deal in the PFAS space. Aclarity is a destruction company. We actually actively destroy the PFAS molecules in the waters that we treat. The reason, or why, what's the call to action basically behind PFAS remediation, especially in the military installations across the country and across the world. There are many multiples. Pretty much every state in the union has got a military installation that has a PFAS problem. That together with the other important market space are landfills that are also operated in pretty much every state of the union here. Landfills are producing PFAS. They are what is known as a kind of a passive contributor to the PFAS problem, right? They take in either residential or commercial or industrial waste from every household or manufacturing operation, what have you, and they accept along the way a lot of PFAS contaminated materials. These materials end up in the landfill, and as it rains or as groundwater percolates through the landfill, the waters that are leached out of these landfills are heavily contaminated with a wide range of PFAS constituents. So they've become the first industry, I guess you would say, that's been forced into serious regulation and have had orders to do things to treat this PFAS, do some type of treatment. A lot of them are looking to do not just capturing the PFAS and sending it back into the landfill, but to actually start to do destruction of these molecules. So that's kind of the background of what the problem is, and the problem is growing across the country. There is not federal legislation at this point, but it is under review and it's coming soon. So it's kind of a state-by-state regulatory approach for now. What Aclarity is put on the table and is bringing out, especially to the landfill operators around the country, is the idea of disposal is no longer the answer. You cannot just capture the PFAS with activated carbon or ion exchange resin or something and then put that back into the landfill just to have it leached again, right, later on and just keep the problem going. You need steps which will actually destroy the PFAS molecules, these fluorinated carbon chain polymer type molecules. And that's what Aclarity has brought to the table. The company is probably TRL level 8/9 at this point. We've done multiple scaled up pilots of our technology across the country, pretty much all with landfills, some with central wastewater treatment plants that accept landfill leachate into them. We are ready. We basically have built and are about to deploy our first commercial system to a landfill site here in New England. I'm talking to you from Boston, Massachusetts, by the way. We offer the commercial systems either as a capital sale to our customers, but more preferably, we like to do this as what we've coined as destruction as a service, using our systems at the customer site where we operate, we maintain, we ensure that the performance over time is meeting the requirements for discharge of clean water. The idea behind this is that we are reducing the customer risk, right, by taking the ownership of the treatment process at the landfill site or at the wastewater treatment plant site. It's good for us because with first systems going out into the world, we are ensuring their success. We're doing what it takes to run these over time as successful projects. The idea is to build our reputation in a positive way as we go out into the world with this technology.
1 minute
How
warning.
does this, oh, thanks. How does this technology work, right? The base technology behind this is very mature and has been used for years in different types of chemical oxidation, usually reducing organics in wastewater streams for discharge into public treatment works. In this case, we have beefed up the technology, applying power to specialized anode-cathode pairs within a reactor to create free electrons that actually break the carbon-fluorine bond. That's the key to destroying PFAS. So it's a beefed up electrochemical oxidation process that we're running in our systems. The system itself, the commercial system, is an 8-chambered reaction system that is treating 10 to 15 gallons per minute per system. This is the form factor that we've chosen to go out into the market with. It fits very well with the flow rates and PFAS makeup of the first application space, which is the landfills, the landfill operator companies, the large multinational companies such as Waste Management, Republic Services, groups like that. We're basically ready to deploy this system onto its first commercial customer. Military bases with contaminated groundwater are a good market as well. We're in the process, we're applying for an ESTCP grant to do a project together with an engineering firm and another another company in the space that does PFAS concentration. So we'll move forward with that, hopefully finalizing it by the end of the summer. Data on PFAS destruction, we're basically taking the inlet wastewater that's laced with the PFAS and reducing it down below either detection limits or permit limits that the companies we work with have established. These slides show us treating a very concentrated stream up over 4 million nanograms per liter of total PFAS on the left-hand side. And then the right-hand side, the upper and lower, are treating concentrated streams after RO, reverse osmosis, pre-treatment of the PFAS wastewater, or thermal concentrate. Thermal systems used to reduce the volume of leachate in a landfill environment will treat the bottoms or the what they call the mother liquor from those systems as well, and zap and break down the PFAS.
15-second warning.
Oh, thanks. This is the last slide I need to go through. The company was founded back in 2017, so it's 7 or 8 years old. After a first seed round that was raised a few years ago, we just went through a Series A at the end of last year. It is a women-owned business, and we're up to 25 employees. Some remote, but most out of the Boston area office that I'm at today. We have partnership agreements with Xylem, who's a big water treatment company, Denora, and then a few other companies that we've partnered with in the industry. So that, all that being said, I'd love to take some questions.
All right, great, thanks. So we have our first question from Richard.
I really appreciate the presentation, John. Just a couple of quick questions. One, I think I looked at your website. You talked about can you get the PFAS out of the soil, one of the biggest challenge, right? And then put that through the system. And the other one, just real simple. Have you talked to anybody at the Navy about participation in the ESTCP that you're putting in?
We have not talked with Navy about that. I believe it's a naval air base that project will be performed at. So we're working as a sub to the primary engineering firm that's done the ESTCP grant. Sorry. The other, we have done lab testing of what our clients have called soil washing operations, which were quite successful. It's basically you're either extracting a liquid from the soils that are contaminated, And we're treating that basically leachate from that soil washing process. So that's how we interact with that type of process. One thing I should mention is that our systems, they are able to work on quite compromised wastewater streams. We usually work at the very front end of a whole wastewater treatment system. And the idea behind that is that we're destroying the PFAS below the required limits before you're going through any other processes that might create a sludge, a solid that needs to be disposed of. Our work is in the liquid phase, and we like to keep the PFAS out of any solids that are being disposed of after the fact, because it's that much harder to remove the PFAS from the solids.
Thank you.
You bet.
All right. Well, that's actually all the time we have for questions.
Thanks. I know you've got to catch back up again. Yeah.
But yeah, thank you so much, John. It's great. And please leave your contact info in the chat. And you actually did generate a lot of chat activity and activity in the Q&A. So be sure to see what some people wrote.
Go through that now. Thanks.
Yeah,
all right, I'll
sure.
stop sharing, and have a good afternoon, everybody.
Thank you. Thanks so much. You too. So with that, we'll move on to our next presentation, which is Spinchy. And for that, we have Irving here to present.
Here I am. Okay, let's do the screen thing. Okay. And do this thing. There you go. So thanks. Spinchy is a spin out from our incubator. Our incubator is launch companies worth about $1 billion. This product is intended to boost energy storage and power by orders of magnitude, and there's a bunch of applications that are shown over here. There's just a lot of need for storing and releasing energy. I'll go into that again. Okay, so what are the pain points? There's a civilian side and the defense side. And the civilian side, people have range anxiety. They'd like to be able to travel as long as they want. They don't want to get stuck in cold weather. They don't want to wait for half an hour to be charged. For aircraft, electric vehicles, weight is a problem, and range is obviously a problem. Offshore energy generation and grid resilience, the bigger your energy storage is, the harder it is to put out at sea. And we have applications also for high voltage DC transport. And finally, there's energy transport. People don't think that you're actually just moving energy around from continent to continent with pretty unsafe vehicles. And that's potentially something you could do if you really had energy storage that was very efficient. You could do that. From the defense side, range is important for drones as well as weight and size. Again, energy transport is a security problem for operations who want to be able to tolerate extreme temperatures. And there is directed energy weapons, and so you need energy storage for that, especially if you're going to do it from a ship or from a plane. So here's kind of how we fit into the scheme of all that's out there. What we're offering are these high voltage, high energy Maxine capacitors. So what is the importance of high voltage? Well, the energy stored in a capacitor is 1/2 CV squared. And so if you have high voltage, then you get the square of that voltage. So you can really boost your energy a lot with that. And for people who say, oh, that's crazy, you can't have more energy than jet fuel, I'd like to remind you that the people who do inertial confinement nuclear fusion, for example, at Livermore Labs, they do not simulate nuclear explosions or create nuclear power using jet fuel. They use capacitors. And so we are an outgrowth of that technology. The advantage we have is we're using Maxine. And as I'll show you experimentally, we've shown, and everybody confirms, that Maxine has something like 10,000 to 100,000 times the energy storage of conventional capacitors, the conventional capacitor materials. Okay, so there's energy, which is how much you store, and there's also power, how fast you can deliver. And that can be a problem for things like batteries or even jet fuel. Capacitors are used when you need to have a lot of power fast, for example, for directed energy, or if you want to charge a car in a fraction of a second rather than 30 minutes. Okay, so here is kind of a schematic of our device. We have 2 patents filed for this, and this is our experimental data, and other people have even more optimistic data for capacitance per volume using Maxine as opposed to conventional materials. So it is a proven technology. Again, going kind of drilling down to civilian use cases. So there's consumer vehicles, and in which case we replace gasoline or lithium ion batteries. We've verified that our capacitors work well in the cold and the heat, and we'd like to be smaller for offshore stuff. And for energy transport, again, you want to you'd like, why have all these big floating bombs, transporting energy? If you really have something that's just as efficient and doesn't explode when you hit it. For military applications, again, you want to have longer range. You want to be lighter and smaller. And if you're in operations, you want to be able to carry it around. And for directed energy, again, that's what people use to create nuclear fusion capabilities. So that's what they use as capacitors. It's just that ours are going to be smaller and lighter, which is important for people who want to build realistic systems. So competitive advantages, it's very high energy density, and it's not reliant on foreign supply chains. We use materials that can be recycled, and as I point out over here, and it'll have a longer lifespan than batteries, as is known for capacitors, and non-explosive and very fast charging. We have had our capacitors tested by independent testing laboratories, and they went up to the limit of those laboratories, and we're going to work on finding laboratory independent testers who can do higher voltage testing as well. So why are we here? Well, we are applying for grants from Defense as well as Department of Energy. It would be very nice to have letters of support and memoranda of understanding, particularly from the Air Force. And we'd like to partner with industry to boost up our TRL, and always happy to talk to investors. We have done this in the past, so Dr. Meir is on this call. He is the material scientist who is expert in nanomaterials, and he's the guy who's made this work. And I have expertise in pulse power. So here on the bottom, this is a water capacitor. This was the largest water capacitor ever built. It discharged hundreds of thousands of amps in nanoseconds. And so I know that. And I've also been a serial entrepreneur, and we've built many, many products that have been used by many, many people. So that's it.
Thank you so much. With that, we'll open the floor to questions. So if anybody has a question, just raise your hand and we could get started.
Sorry, I don't know how to raise the hand here. I have a question, 2 questions in reality. One is about the self-discharge in comparison, like how long can they store the energy in comparison with batteries? And also if you could talk about the cost and the price points between your solution and other storage solutions. Thank you.
Yeah, so I'd be happy to talk with you further. Just to answer very quickly, is capacitors store energy for a very long time. That's you have to be careful about that if you have a capacitor in your house. Make sure that the terminals are touching each other. Otherwise, it can be a year later and you'll still get zapped. And we have seen very low leakage current in the samples that we have built. And the second question was in terms of cost. And so we looked at that as well as looking from recyclable materials. And so the cost right now, for example, the high voltage DC people are charging $75,000 for a capacitor, and we can make that capacitor a lot smaller. And in cars, batteries are, I think they're 40% of the car. So this is a field where there's a lot of fat, but the intrinsic material is available in the United States, and like I said, can be recycled. So it's not very expensive. I hope, and I'd be happy to talk with you further.
Thank you.
Great. We have time for another question if anybody has one.
This is Dan in Austin. Can you hear me?
Yeah.
Yes.
Uh, I'm very enthused about your product and your company. I just have a few questions and one comment. High voltage, usually these super caps are no more than 20 volts. What is your maximum sustained voltage on the device?
Oh, that is exactly the right question. That's exactly the right question. And I didn't go into it, but that's the reason why we're better than ultracaps, because you have 1/2 CV squared. The ultracaps have very high capacitance, but can only tolerate a little bit of voltage because because you're talking about 8 nanometers that they have to hold off the voltage. So in our case, what we have is a mixture of Maxine, which gives you high dielectric constant, ENA plastic, which has high dielectric strength, and the high dielectric strength allows you to hold off kilovolts. So that's the difference. And there's not a lot of people who work in this field. You have to be careful about high voltage, but like I said, I've done that, and the people in our lab are trained to do that, as well as to convert from the high voltage to other voltages when required. So if you have to put it in a car, you're going to have some ancillary stuff that'll take you from the kilovolt that they run. Right now they're running at about a kilovolt, and you want to be able to go, let's say, from 10 kilovolt to 1 kilovolt. So
Oh,
we have
I
those
see.
circuits
That's
now.
interesting. Okay, so what is that high voltage? This is unusual. What is the maximum or the typical operating voltage?
So we have different applications we're looking at. 1 kilovolt, we have an application for. 10 kilovolts, we have an application for. And 50 kilovolts, we have an application for.
Okay, so if you're running it at that voltage, which is
No,
surprisingly
you have a different
high,
capacitor for each range. Yeah.
any of those voltages are much higher than the typical application voltage. So you need power conversion to bring it down from high voltage to low or medium voltage at 12 volts or 600 volts in the car, for instance.
Yeah, absolutely. But gasoline also has its dangers. So yeah, you have to be careful.
And how many farads is one capacitor? Its capacitance value typically, or range there that you make.
So we like millifarads or tens to hundreds of microfarads.
Okay, so rather than the low voltage farad devices, these are sub-farad, but you make the point that at these very high operating voltages, they still the energy in joules is substantial. It just takes power conversion.
Right, that's the 1/2 CV squared part. Yeah, so it goes as the square of the voltage. Exactly right. But the key part is also the ability to discharge rapidly. So I'm talking to the people on the defense world over here. You can't do that out of a battery. You'll get 300 amps out of a battery, but not 300,000 amps out of a battery. So I'd like to
this
talk
could
to
be
them too.
used for rail guns and satellite killers.
That's what people do with capacitors. Yep.
And what is the ESR, the effective series resistance, which is another measure of a supercap or ultracap compared to a battery? There's some equivalent resistor model at the terminal.
Yeah, it's going to depend on, as I mentioned, we're a composite, so it'll depend on the composite, and we're still looking into that. So, this is an area of research, and we'd be happy to talk with you. And it may depend on the application.
Okay, I'm going to pay attention to your company. 2 years ago, Tesla acquired Maxell, the supercap company out in Anaheim for big bucks. So you could be the next acquisition candidate or investment candidate.
I work with Maxwell capacitors quite a bit. Yeah, so I know that technology quite well. Thank you.
Thank you. Good luck.
Irving, this is Javier. I'd be happy to try and help you find some MOU signers. I'll follow up with an email after this. I'd love to see the proposal that you've put together and shop that around with some of our Air Force and Space Force friends.
Great, thanks. I put my email in the chat. Thanks.
All right, perfect. Well, thank you so much, Irving. That's actually all the time we have, unfortunately, but it was great. And we see you have your email in the chat. I do see there's one question in the Q&A, so about the energy density. So if you want to type the answer to that, yeah, you can. and or whoever's interested in that could reach out to Irving. With that, we will move on to our next presentation, which is U.S. GeoMetals.
All right, let's see. I am getting it to blow up here. There we go. Can everyone see it okay? I think.
Yep.
Yeah, my name is Brian Mueller. I'm really I'm the CTO of US GeoMetals, and our company is focused on sourcing lithium from existing US geological waters, and more specifically, produced water from oil and gas. Our vision is right now is actually to be the first to demonstrate this. And we do intend at the time, things are moving pretty rapidly in this space, but right now our intent is to be a supplier of lithium products. So a producer, not a service provider. We want to deploy a scalable and economical offering, where we've focused on low capex infrastructure approach, right size factories using existing wells. And when I say mobile and modular, literally things that you can put on a skid truck, whatever, move down the road, follow the water. And we want to be the first. Here's kind of I kind of put this slide together like yesterday, and I said, because the problem goes beyond, and I kind of list here's all the problems, and obviously lithium, there's some supply chain issues, and everyone kind of understands that, and EVs are really driving the demand. But Saylor and hard rock, part of the other issue is Saylor and hard rock mining are very environmentally unfriendly. They're very greenhouse gas emission intensive, energy intensive, and they use a lot of water, especially in water distressed regions. And also importing these minerals, you see what the cost of lithium carbonate is, but people don't really take into account what it actually costs to get it to the U.S. And also the U.S. we're short on other rare earth minerals, and so there's not a lot of best practices in existence to mine these geological streams yet. And the other thing, in oil and gas, there's a large volume of water that has been linked to seismicity and groundwater contamination, and we can eliminate that and actually create a source of usable or maybe even beneficial reuse water. And there also exists thousands of uneconomical, abandoned, and orphaned wells, and this would actually also opens up this may end up being a preferred way to deal with those. Our proposition is to focus right now on oil and gas wells. We're going to leverage existing brine resources and no new wells. And we're also going to, and the thing is, once you start mining one mineral, it really opens up the door or changes your assessment and what's it take to get additional minerals. And some of them are critical, some of them aren't. I mean, calcium could actually be produced from some of these streams. And there is the opportunity to save water. And I'm not going to read everything that here. I probably got more information. This is what we have is, I think, a real unique investment opportunity. We've been able to stay technology agnostic. So basically, our process is a combination of some licensed technology as well as stuff that we've internally developed. We've never done experiments on synthesized brine. This has always been done on real brine, and our goal. We've always tried to move beyond rhetoric and really present a credible process. And just to kind of show you, we're a bunch of oil and gas guys. That is an actual proposed map, how we could actually integrate our process into an existing and operating oil and gas site. So our intent is really to take advantage of what already exists. Okay, here's kind of, I'm going to kind of jump through these next two slides. There's way more information I'm going to talk about, but what I want you guys to grab from this is the key enabler of our process is that going from that first blue tank to the second one. When these oil field brines have very low concentrations, probably 50 to maybe 200 ppm. And the biggest thing you need to do to enable an economic process is deal with reduce that large volume with essentially no no energy or no chemical consumption early in your process. And then from there, you got a lot more latitude in how you can approach this. And that's kind of been our focus from day one. And you know, we've done, and we're not, this isn't a small scale experiment anymore. We've done this at 10,000 gallons twice, and both time, and our second one was better than the first one. And this just shows you like one of the big things we have to get in that first volume reduction step. We get the lithium. We need to get the lithium up by over a factor of 10x improved, and we also have to get remove a good chunk of the impurities. If anybody is knowledgeable in this space, this actually lends out, I think, the real credibility. These are real KPIs. These are all real data points that we've actually done in lab. And this process, if you look at these process flow, I mean, if you went to a conference, you'd see a lot of people that are already in the space. They'd have those same boxes with arrows, but they won't show numbers like this. And this really brings a lot of credibility. And I'm not going to show you an economic model, but it's pretty simple. We've got a calculated cost, and when I say conservative, we pretty much multiplied everything by 2, and so we're hoping to be a lot lower than that, but that's kind of what we're planning on. And we've also done our economics on around 70 ppm of the incoming brine. So obviously, a place to improve that would be a higher. I think we're ultimately going to produce at a higher level. But the economics are pretty straightforward. I got there the kind of what people expect the costs to be for lithium carbonate equivalent, and we're going to make it for a lot less than that. We've also got this is actually more engineered than you might think, but this is kind of a timeline that we're kind of proposing, where, you know, when we get the funding, 0 to 6 months to really show that field demo site, because like I said, we're taking the pieces and we're putting them together and automating. We're not inventing anything at this point. And then we've got a pretty aggressive timeline and plan if everything works out to get this thing to a sustainable business. Anyway, I'm kind of probably moving faster than I needed to, but we've created this is our ask. We've created a viable solution. This is we've completed 2 10,000 gallons and a demonstrated 95% lithium recovery. We still want to be first in this space. We've got novel IP, and we also think just some of our approaches have the potential to be disruptive in contrast to some of the ideas out there that are very large and very CapEx intensive. I do believe this, and I'm an inorganic chemist, PhD inorganic chemist, and I believe that brine mining will be the preferred source of lithium production. I say that, and you can look at me and say, well, how come no one's done it yet? Well, like I said, I still believe it. 3, we're developing projects. We've been engaged with. We're right now engaged and courting 3 sites to be our potential first. And we're really going to put this is going to put Texas, Arkansas, and Louisiana on the map for lithium production. Our funding request is we've got that initial investment of $3 million to really fund that field development, and then we've also got a number to go to a self-sustaining business, and we think that can be done in 18 months from when that we initially start that demonstration unit. That's all I've got. Again, we're US Geometals, and I'm glad to answer some questions.
All right, thank you so much, Brian. So yeah, opening the floor to questions. If anybody has a question, just raise your virtual hand in Zoom, and we'll get the ball rolling. Yeah, Lynn.
Hey, quick question. Just trying to understand whether the long-term goal here is for you all to continually be the developer here, or to leave the IP to existing mining companies to use sort of on their sites with their existing brine.
You asked a question. Long term, I don't know. I mean, we're going out with the plan to be a producer, and we're promising lithium carbonate as our sellable product, or lithium carbonate equivalent. But there is so much going on in this space, and a lot of people's tech is evolving so fast, and there's some people doing some pretty significant investments. We could end up being a lithium chloride producer, or we could also end up being a service company that just kind of went into went to operators or people that had these assets, and just service them to produce lithium. But our business plan right now is built on being a producer.
Can you just explain why that is? Like, why choose that as the first state, given you have to sort of acquire the assets as well yourself? Is it the de-risking piece?
I think it's the type of investors that we're kind of courting right now. That's probably honestly, I'm the CTO, so I'm not the business guy. He'd probably give a slightly different answer on that, but that's we're in oil and gas. I mean, but that is a very good question.
Thanks.
Great. Thanks. Our next question is from Tito.
Good question on, you say lithium carbonate equivalent. What do you mean? Is this like battery grade lithium carbonate?
Right.
And how far are you from sending samples to potential customers? Have you collected sufficient amounts from the first batches that you did? Is that something that you've been sending out?
We have made lots of pounds of lithium carbonate in our lab, but no, we have not started sending it out. No.
Okay.
I mean, we checked the purity. We checked the purity. I mean, we've been able to self-fund, and we have we're fully capable. We've got an ICP OES. I mean, all the necessary analytical equipment and stuff. So I mean, we're confident in its purity, but no, we have not. That is something that will probably happen as we do this field demonstration unit.
Absolutely. Yeah. If you're interested, we can continue the conversation offline. We purchase a lot of lithium carbonate.
Okay, great. So we have Ariel, and then we'll finish up with Tom.
Great, thank you. So we at CEV have actually been doing quite a bit of diligence in the lithium space recently, and there are many players all trying to catch a falling knife right now. What makes you confident that you will be the lowest cost solution?
Well, okay. So when I say we're lowest cost, I know what our costs are. And I know, and there's several very available public third-party reports out there from all the big brine. I mean, so I do believe that I think I'm probably getting two things mixed up, and but the cost that I presented, like $6,000 or below, that's built on me actually measuring how much chemistry I'm going to consume, how much I'm making assumptions about the capex, making assumptions. I mean, that's it, and like I said, we're drawing those up. I look at what other companies are doing, and and probably one of the big places we save money is on the capex. The other thing is because we don't have to do a whole lot up front. We're taking things from our existing assets. So it's some of it's a little bit apples to oranges. Some people are they're building their economics around other alternate productions like bromide production. So like I said, I'm confident because I see it. I mean, I'm the physical inorganic chemist that actually does the experiments. I've been involved from the 10,000 gallon to getting 10,000s. And so like I said, my confidence is built on that. And I do believe brine mining will be the lowest cost. So I think I'm saying that more in a general sense.
Sure. As a fellow chemist, I'm thinking more in terms of the thermodynamics. So if you have a brine, it's got some concentration of lithium in it. There is a minimum amount of energy required to use, magic tweezers and pick all the lithium out in whatever manner that you're doing it. We've seen many of these magic tweezers. How close to minimum thermodynamics are you in being able to separate the lithium out? And that might be a conversation for offline.
Yeah, I mean, that'd be good. Better one under an NDA, but it really goes back to that first step. All right. That doesn't require any chemistry, doesn't require acid or base, and it doesn't require an input of energy. Okay. It acts thermodynamically. It actually uses the inherent properties of the brine. We need high TDS brines. They have to be a fairly high TDS to drive the thermodynamics. So we're using the inherent characteristics of the brine. Yeah, when I first started describing this, kind of your question was perfect. I listen to myself and I go, my gosh, I sound like I'm a perpetual motion machine. But no, there is actually a thermodynamic drive. I'm a physical inorganic chemist. I wake up at night going, geez, did I miss something? But yeah, it'd be worth taking I love your question, and I'd love to have a further in-depth discussion about it.
Great, thank you.
Mhm.
So I guess as a last question, so I didn't think I heard the actual technology. Are you absorption, filter, filtration, or what are you doing?
Yeah, so the first step is a liquid solid, kind of like ion exchange step. And then there is also another upgrade step in there. I'm just, like I said, little NDA up, and I'd be more than happy to tell you. But the big thing is, like she said, like the first step is very chemistry non-intensive. The second one, yes, you have to almost assign a certain amount of acid, or a certain amount of chemistry, or a certain amount of energy to get to that next upgrade step.
And is this your technology? You have the IP, or is this something you've licensed in?
So we've patented the overall process, and we do have some of it. Some of it is homegrown. Some of it we have licensed. When we entered this, one of the things I realized that there's a lot of people out there making claims, and there's a lot of people say, "Hey, we got DLE." And one of the things we kind of had to rapidly filter through is that there's a lot of good tech out there, but no one has, quote, that whole thing. And so you can start so being able to piece together what's the best way to do this is one of the things that we've been able to do.
Thanks.
Mm-hmm.
Great.
No, like I
Thank you
said,
so
I'll
much.
stand behind what I've made claims in here that obviously I can't back them up in this kind of a forum, but I'm very optimistic.
Great. Thank you so much, Brian. Please leave your contact info in the chat so people can reach out, connect if they'd like to learn more. And with that, we will move on to our next presentation. It is Littoral Power. That's in our second session. So we just moved from our first session to second session. I'd like to thank everybody who joined for the first session, all the companies who pitched, all the panelists who had joined. If you have the time and want to stay for the second session, we're not going to kick you out. Happy to have you continue with us. And I'd like to welcome all of the new panelists for the second session, and also the panelists who signed up to stay for the first and second one so far. We had on the agenda to have the panelists introduce themselves at the beginning of the session, but we are running a bit behind just because the presentations have been so good and there's been so much interaction going back and forth, which has been great. So instead of doing a whole introduction like we did in the first session, instead for the second session, as you ask questions in the Q&A and you haven't been asking any questions before, in the session, just introduce yourself briefly and then ask your question, please. So with that, we will continue with our next presentation, which is Littoral Power, and we have Kathleen here to present.
Hi, everyone. I'm glad to have a chance to share this with you. And let me get my my screen shared here. Okay. So I'm from Littoral Power Systems, and what we do at Littoral Power Systems is water power. We are selling hydropower systems, and we are developing marine energy systems to provide clean, renewable energy. And we do define water power broadly, both hydropower as well as extracting energy and converting energy from the hydrokinetic energy in waves and currents, currents both in a river or ocean currents or currents that exist in the tides. Hydropower, we got our start in hydropower. We started developing innovative technologies specific to hydropower back in 2016. We worked hard, and we were fortunate enough to receive funding from the Department of Energy to develop those technologies. And today they are being used in pilot sites and even in some commercial sites. And while we are growing that commercial business in hydropower, we are developing wave energy devices to harness the energy from waves and to convert that into electricity. We are also developing devices that harness the energy from flowing water. Our wave energy device actually is based on a structure, the wave energy structure itself. It's called a point absorber. That's very mature. That technology has been around for a number of years. Structures of this type have actually been built and tested off the coast of Hawaii. What we are doing is we are updating that device with a set of controls that allow the device to respond to respond optimally to each and every wave that comes in and hits it, so that we can optimize the energy output. Wave energy is a huge opportunity, but no one has been able to figure out how to do it really economically. And we believe the pathway to do that is to make the device perform optimally by having artificial intelligence and machine learning enabled controls. Those controls will be tested in a wave tank here in a couple of months, then will be tested out in the open ocean with the actual device itself the following year. We also have a relatively mature tidal turbine. This is a turbine that is actually designed very specifically for lower velocity currents. Most of the waters of the United States run at velocities around 2 meters per second or less. And this particular turbine has been very specifically designed to optimize the power output from those low velocity currents at a lower cost. This device has been tested in the Cape Cod Canal. This is a picture of the device. It's about 3 meters in diameter. And we are looking for opportunities here to take this to the next stage and into pilot scale deployments. We've gotten traction. Like I said, we got our first our first funding came from the Department of Energy back in 2016. Since then, we've in total we've won about $21 million in R&D contracts so that we can actually develop these products and get them to a relatively high level of maturity. And we've had success in commercializing them. We also have been very jealous about IP. We have a good IP portfolio. 3 of our patents are awarded, and we've got 9 more in the pipeline to protect the designs that we are inventing and developing. And we really are proud of the commercialization efforts that we've exerted and that we're being successful with. In hydropower, there is a segment of hydropower that is growing, and it's growing at a reasonable rate. And that's the segment of hydropower that it focuses on smaller dams, on smaller energy production, somewhere less than 40 megawatts, per installed site. That particular segment of the hydropower market is easier to license in. It's got a lower environmental impact, and that's where we're focused. And if you actually look at all of the new projects that are happening, either in relicensing or in upgrades to non-powered dams, you'll find the name Littoral Power Systems associated with about 60% of those. So that's the area that we're focused on, and we are growing, in that market. This is the team. I don't know too much to say about the team. We're experienced, we're good, we know how to commercialize innovations, and we're having a success in hydropower, and now we're turning our attention to bringing the marine energy up to that same level. We're looking for research partners, research and development partners in 2 areas. One is to take our hydropower technologies now and actually turn them into turnkey microgrids. Our hydropower technologies are prefabricated. That's one of the ways that we've driven down the cost, is by actually prefabricating the civil works modules. The civil works are a huge part of the cost of any hydropower installation. It takes a long time to pour the concrete has to cure. So what we do is we build the modules ahead of time, then we bring them to the site and we assemble them. That opens up the opportunity for a faster installation. We're looking at building plants in maybe 25% of the time or less than it would take to actually, build them as an on-site construction effort. And we're also looking for memorandums of understanding and research partners to now take our marine energy equipment and pilot that marine energy equipment, for instance, off the shore of islanded communities, to provide energy for the islanded communities by harnessing the energy in ocean waves or in tides, as well as along rivers. We've looked at least a number of the Air Force bases and are considering now at Army and Navy bases. But we've found over 66 just Air Force bases that are close enough to a body of water that water power could be part of the solution for the energy needs of those bases. Thank you. It was short and sweet, I hope. And if you have any questions, please get hold of me. And my email is right there.
Sure. Thanks. Thanks, Kathy. And we actually have a question right now from Lisa.
Hi, Kathy. A great presentation. And I've been a big fan of micro hydro for a long time. Used to live in Vermont where we tried to do it 100% unsuccessfully. Not my company, but just people in general. So here's my question. And if you could explain it to a chemistry person and not an energy person, what would be the smallest sort of water flow that would make sense for your technology? And I'm thinking like river size, maybe how many feet across? And then why can't it be smaller? Why are small microhydros, maybe community level, so hard to put into place, whether it's from permitting or maybe the technology just isn't cost effective? So how small can you go and still be cost effective? But don't say kilowatt, because I don't understand.
Okay, so well, let me put it. So Lisa, in my residence, my house right now, I've got 3 kilowatts of solar panels on my house, and that completely powers my house. And so I think I am going to use kilowatts, but I'm going to try to I am going to try to calibrate you in terms of what is a kilowatt. And so I think that when we're thinking about hydropower, we've got a higher capacity factor than solar. So about 1.5 kilowatts of hydropower would do everything that my 3 kilowatt solar panels are doing right now. So if you think about maybe we need 1 to 1.5 kilowatts of hydropower to operate a nice sized home. And that I think our smallest unit that we've sold and installed has been 5 kilowatts. So small. It was actually for kind of a famous musician person that wanted to have hydropower on their property, and so we were working with them for a small 5 kilowatt machine. So that's going to go on a river that might be less than 100 feet wide. Maybe it's only 50 or even 20 feet wide. But what's more important is the height. How high is the dam? What's the head drop? And so you need to be able to have a depth of water or a head drop that is, it's got to be close to 10 feet. Maybe we can do it at 7 feet. That's the real critical thing, is how much elevation change do you have in order to build up the pressure to drive the hydropower turbine.
So when you think about installing systems like that, and then I'll be quiet, are there places in the country that are more favorable to get permitting for these kinds of things, and other places in the country where it's just harder to get permitting because the water is more protected? I know Vermont was tough.
Yeah, so it really is kind of watershed by watershed. And certainly if you're on a wild or scenic river, it's difficult. I mean, it's very difficult to do it there. But when you there's an organization called LIHI. It's the Low Impact Hydropower Institute, and they have been advocating for low impact, ecologically friendly hydropower. And so working with LIHI and following the LIHI prescription, it's much easier to get things permitted. But wild and scenic rivers are tough.
Thank you.
Great, thanks. We have another question from Lena.
Hi, yeah, thanks for walking us through this. My question is more sort of on the interconnection side of things. I think you sort of started to touch into this. A lot of grid infrastructure is not necessarily in the same place as waterways. And building out that infrastructure might make sense when it's a large hydroelectric dam, but doing that a lot for these smaller power systems seems difficult. Can you walk through how you all are sort of addressing the interconnection piece?
I can give you some information that I'm not really the expert in that side, but certainly, I mean, the first thing that we look for is the opportunity to be near a substation. And there are some wonderful tools that Oak Ridge National Lab has put together that are super helpful. I mean, I can get on the internet and I can identify a location, and in a few keystrokes, I can find out how far away is the nearest substation. And so, certainly we want to look at locating projects, near the substation in order to minimize the cost. The other thing that we look for are opportunities to provide power behind the meter, where we're not actually supporting and not connecting necessarily to the grid itself, but, providing power to a grocery store, or one case we're looking at is providing power to a pipe manufacturer. And so that's another thing, to look at.
Thanks. And we have our final question from Richard.
All right. I really appreciate the talk, Kathy. I have more questions than we can get to, obviously, here, but one quick one. Are you connected with the Pacific? I'm assuming you are connected with the Pacific Marine Energy Center in Oregon,
Yes.
Washington, Alaska.
Yes.
So the Navy, NAVFAC X-Ray, the organization I'm with, so that they are the lead for marine energy for the Navy side. And I'd like to connect you up with them. I've worked with Alaska, the wet side out in Hawaii, and all the different organizations, and microhydro myself over the years when I was with NAR. So if you can, just make sure we get linked up, and I'd like to get you directly in touch with the people there at my current organization.
Great. Would love it. Thank you,
Thank you.
Richard. Really appreciate that.
So, well, thank you so much, Kathy. Be sure to leave your contact info in the chat so that people could know how to reach you after the contact info that you're displaying now is off the screen. And with that, we will move on to our next presentation, which is Margic. Okay, I saw Margaret on here. Oh, yep, I see she's here. Let's see.
Mic check, mic check.
Okay, now we hear you.
Okay, not sure why. Okay, here we go. All right. Well, thank you everybody for having me today. Really exciting talks earlier. And today we're going to start with more of a global problem, which is the lighting and the power grid issues become more and more prominent as humanity, we begin to use more and more lighting. And there are several issues that come out of that. There's resilience, that is cost inefficiency. There's problems with supply chain and simple shortages. And we're not only talking about the lights that are constantly on, like your household lighting and street lighting, but the effects also come from now recharging your vehicles, all the electronic devices in your kitchen, and so forth. And the problem is that the landfills continue to pile up with electronics to a point now we have more actual supplies present in those in the landfills than we have left in the mines to actually make the electronic devices. And the problem that we're specifically addressing is insufficiency in the LED specifically, as LED right now became that global solve-it-all solution, but it's not great for everything. They consume a lot of energy, they generate a lot of heat, and there's problems with ruggedization, and they still use the rapidly declining resources and raw materials that are necessary and simply won't be available in the near future. So Margic solution provides an opportunity for lower energy consumption. We have proven already up to 30% decrease in the energy consumption. We minimize the heat by 95%, and these are made for durability. So these are ultimately ruggedized devices to start with because they're made for rugged conditions, not for stationary objects. And where we do have a defensible solution for this, we have kind of more of a comprehensive portfolio from perspective of patent portfolio on materials to manufacture the organic LEDs and how to manufacture those organic LEDs. As well as we have manufacturing patents that accommodate the fact of organization how to connect the LEDs to the PCBs and etc. to make sure that they are as efficient and as durable as possible. A little fun fact, Margic was the first company that got all 7 yes from all 7 judges at Unicorn Hunters over the 2 seasons. And we're really excited for the opportunities that really enable us to move forward with. As far as the market that we're addressing, the lighting market is over a $1.5 trillion industry. We're specifically focusing on some of the outdoor emergency lighting opportunities and indoor lighting opportunities, as well as transportation lighting. And our really target markets are being two-wheelers and emergency lighting specifically for that. As far as competitive landscape goes, we are competing against the current LED solutions as well as other companies that provide organic LED-based solutions. But what we realize that our customers require power efficient, non-heat generation, sustainable, cost-effective lighting. And there is really not a solution that could accommodate each one of those buckets. And Margic has the power to do so. As far as a customer work previously, we've been able to work with some of the automotive folks to increase the brightness of the devices while improving the area of light and visibility, lower the heat production, and bring back 40% of that energy utilized by lights to the automotive device. As far as our Air Force work, we have an active Air Force contract to develop durable light for really cold environments specifically. That would be waterproof, magnetic panel that you can attach to different surfaces, and you can see how bendable this panel is. And we already have achieved 200 feet distance visibility and 16 hours of operation without needing to recharge the device. As far as market rollout, we are on target to receive purchase orders from commercial segment up to $1 million. With the smaller items that we're currently working on, and then we'll slowly move our way along the B2B and licensing opportunities to reach that $1 billion opportunity. As far as attraction, like I said, we've been working with government contracts first, National Science Foundation and Air Force, but we also commercially sold over 1,200 units within motorcycle and packaging customers and building up our purchase order portfolio as of this moment. As far as our team goes, we do have over 90 years of experience in lighting manufacturing, 8 full-time team members with experience in both manufacturing and commercialization. And we do have a strong advisory team that enables us to bring the maturity to the company. And we are currently on a pathway in this early stage of fundraising, which we realize there's a long pathway ahead of us as well. And we are raising $500,000 and we're applying for one-to-one matching opportunity. And that is to provide the warehouse ability and production and the scale-up opportunity to attack the beachhead market and provide the success stories for growth opportunities in the future as well. And with that, I would like to take your questions.
All right, great. Thank you so much. So yeah, opening the floor to questions. If anybody has a question, just raise your virtual hand on Zoom. And we could get the ball rolling. I'll just start, maybe get the juices flowing here for everybody. Could you just talk, you mentioned it a bit briefly, some of your previous Air Force work. Could you just talk a bit more about what you've done with them so far?
Yes, so the solution that we're providing for them is a flexible panel that can be attached to different surfaces during the preparation of flight operations, and which is usually done in heavy snowfalls, winds, rains, all of that good stuff. But because of the flight base being very mobile and constantly altering, there is not like a light pole you can just have available. So that's what our solution is meant to address, is providing visibility of for the stationary objects. So that way, while the crew is preparing the site, they do not crash into objects. They see where their objects are and they can follow the pathway.
Awesome. And I see we also have a question from Rick.
Yes, hello. I was wondering if your sort of the bulb specific part is compatible with the existing infrastructure, the drivers, power supplies that are for other LEDs, or if it requires some reinvention in the value chain to bring you to market in everyday products.
Oh, correct. Yes and no. So right now we've been mostly embedding products for the automotive industry, which we just readjust the connectors to match their connectors. A lot of times we're still replacing halogen bulbs. So basically, instead of the socket for the bulb, we're directly plugging into the connector for the wiring as well. But because of our diversity, we only require 3 volts to power the device. We can up convert all the way to a truck with 24 volts or your traditional household lighting. As long as there are wires to connect to, we can do so.
Great. I also see there's a question in the chat. Someone asked, what are the lumens oh my God, I'm blanking here, per watt output of these modules?
I don't have the exact number off the top of my head. So I don't think I can bring it up that quickly. I can attempt. Let's see if I can get, I think we have Candella's measurements. If there's another question, maybe I can talk through it while I'm
Margaret,
searching.
this is Javier over at Ensign. Are there use cases you've thought of that you'd like to get in front of DoD partners? Are there problems that you see as kind of low-hanging fruit for the department that you can help solve?
So right now I've been discussing sensor capabilities. So one of the projects that was brought up to our attention was using robodogs to send in the field for sensing capabilities. So we've right now developing a patch that can be just magnetically attached to the robodog with a sensor. Right now we're looking at carbon fiber sensors, but other chemical sensors can be embedded as well to send out the robodog in the field. We would use the flashing capability as notification system back to the people that receive that data to improve understanding of the radius of impact for a variety of chemical impacts.
Oh, and your value proposition to that use case is you would be your light would be seen further.
Correct. You can do it either from light. Yeah, from light perspective. They did mention that a lot of the robodogs that currently used do not have any light feature within them. That was one of the issue. The second issue, the data collection problems or simply unavailability of appropriate sensors that can be used with the robodog at the same time. So we're addressing that miniaturization issue, data collection, and the lighting problem in one device. As far as the going back to the brightness, so right now we have current efficiency for 2000 candelas per meter square. And then another device set is for 900 candelas per meter square. That is for OLED, strictly OLED based devices, but we also have hybrid LED devices.
Great. Well, that's actually all the time we have for questions, but thank you so much.
Thank you so much for your time.
Sure, thanks. And we actually have someone in the chat. They do want to connect with you to discuss further. And also please leave your contact info in the chat as well, so that others could reach out to you if they want to discuss further.
Thank you so much for your attention. Have a good one, everybody.
Thank you. So with that, we'll move on to our next presentation, which is Falcon Green Energy. And we have Dan and Paz here to present.
The first thing I want to talk about, good afternoon, everybody. I'm here in Austin, Texas. Battery Park, Texas is a energy development project. The name Battery Park comes from Battery Park in the financial district of Southern Manhattan, although this is here in Texas. Next slide. Let's go through this fast. This is going to be a blended hybrid system. I've now upped this to 500 megawatt hours of battery energy storage because we have a problem here in Texas. We're one of the largest consumers of kilowatt hours per capita in the world, and you may have seen it in the news. We've had a grid collapse twice in the past 3 years. We're desperate for more generation. So a combination of batteries, solar energy, and potentially combined cycle natural gas in the future our grid operator, ERCOT, has put out a desperate call for more energy, and are willing to pay a 10% premium over the market prices today. So this is a very lucrative project, and the real ringer is that the site for this project is 52 acres adjacent to the largest substation in Central Texas owned by the LCRA. This picture is worth 1,000 words. There's Battery Park, Texas on the left, and then the LCRA substation on the far right. There's actually 4 utilities that connect to this substation. So we can deliver energy to any of those 4 utilities, 85 TDOs in Texas, or 600 reps. There's plenty of wholesale buyers for the energy we would create at this site. I'm looking for $2 million to finish the purchase of the land in the coming months. So I'm open to any structure, a convertible note or a equity position, to simply buy the land. Your position as an investor would be collateralized by the land itself. Now, the next presentation, if Paz can move on to Solar Synapse, which I think is a better fit for this audience. This is a real innovation that has a lot of momentum now. Right now, solar panels are not smart. There's no smarts inside the panel. Now, of course, there's monitoring upstream in the inverters and the other parts of a large solar system, but a 10 megawatt solar system, which might be a average size today, has 350,000 solar panels, an inordinate number. So by breaking the monitoring down to a panel by panel basis, which is totally unique in the marketplace today, we turn a silent solar panel into a smart solar panel and collect more data going to maintenance, repair, and optimization of the system than has ever been seen before. So Solar Synapse is a tiny little chipset that goes in the back of the solar panel in the junction box. So it can be either a retrofit adaptation to an existing system, but this year there will be 1.1 billion solar panels manufactured in the world. If we had just 1% market share, we would be a $10 million company. And actually, I need to correct that figure. The market size, it's bigger than that $100 billion. So 1.1 billion panels, 575 gigawatts of solar energy this year, and the solar market is growing at 40% per year. So this is a OEM subcomponent that is going to change this business somewhat and add intelligence and smarts that we don't have otherwise. We can tell if a solar panel is broken, disconnected, stuck in the tracking system, covered with dirt, pollen, or other debris, whether it's cracked by hail, whether it's become dysfunctional in a string, which creates a compounded problem. So we see about 30 different monitoring benefits in the Solar Synapse product. We've, of course, derived the voltage and current, which is available at the same 2 terminals that power the device, but we also measure temperature, barometric pressure, and relative humidity, and collect that data both locally inside the device, but also in the cloud. That's the value proposition. We call it Solar Synapse. It adds smarts to solar panels that don't exist today. And I'm just seeking $5 million in a round A for something that we think we're going to have the pre-production model by the end of this summer. So that's Solar Synapse and Battery Park, Texas. The first pitch of the project, which is probably be acquired by the end of the year if I can raise the $2 million to buy it.
Great. Thank you so much, Dan. So with that, we will open the floor to questions. If anybody has any, you could just raise your hand and we'll get the ball rolling.
I can jump in. Just on the solar synops, there's a lot of, I think, solar monitoring companies and equipment out there, including even sort of, panel level inverters and converters, optivolt, Enphase, things like that. Sort of what differentiation do you envision with solar synops, and sort of what IP do you have to build a moat around that?
Yes, there is monitoring in the inverter itself. There is a trend from larger centralized inverters to micro inverters or string inverters, but these are very prevalent in residential systems where you just have a couple of dozen panels. In a large utility scale system with 350,000 panels, you wouldn't want to use micro inverters and create that level of hookup and distributed failure that the inverters in large utility scale projects are still centralized, typically 250 kilowatts to 1 megawatt per inverter. So there's a segregation between the smaller residential microinverter market and the larger utility scale centralized inverters. And even again, the monitoring that is available in those inverters is only a fraction of the data that we can collect inside the panel itself.
Great. We do have time for one more question if somebody has one.
If Paz can put my contact information in the chat box.
Sure. And I might have missed this if you went over it already, but how much would this add to the price of a solar panel?
That's a fair question. We believe it's going to add 5 to 7% to the cost of a typical 480 watt, or now 550 and 625 watt. There's a trend to larger and larger size panels. And as that wattage goes up, the fraction of the differential cost price between a panel with and without smarts inside is going to decrease over time. We also have a case model that the maintenance cost, that this all came about from a large solar project I sold last year in Smithville, Texas. When we switched it on, 2 of the strings were out, and a string of solar panels, you put 16 of them in series at 48 volts to get a 600 volt string voltage to the inverter. Well, it suffers the Christmas tree bulb effect. When one panel goes out, the entire string goes out. So you not only exasperate the energy loss during that downtime, but the maintenance time is greatly reduced. That took our contractor 2 days to meter out which of the panels in the 2 strings were bad and replace that. We think it could have been done in a couple of hours by just identifying which panel is out. And the failure rate in a 10 megawatt project is 1 panel in 200 will fail in the 25-year life of the panel. If you distribute that across 350,000 panels, you're losing 1 panel every 2 months. So the small 7% increase of a panel price, we believe over the 25-year life of a project, more than pays for itself in reduced maintenance and repair cost and getting back online with maximum energy production.
Makes sense. Okay, well, great. That's actually all the time we have. But thank you so much for your presentation, and everybody. I do see that Dan's contact information has been put in the chat. So if you would like to speak more with Dan or learn more, or if you have any questions, feel free to reach out to him. So thank you again, Dan and Paz.
Thank you.
And with that, we'll move on to our next presentation, which is on dessert. We have Nicholas here with us to present.
And I should point out that's on desert. On dessert is some sort of diet website. That was
Sorry.
Okay, and I'm gonna try and share my screen here. Do you see my presentation?
Yes.
All right, great. Hi there, my name's Nicholas Seat and the CEO of Undesert Corporation, and we are transforming contaminated wastewater into purified, usable water. And here you see a picture of my CTO in front of a prototype device, and we've had our device evaluated at this brackish groundwater facility in Alamogordo, New Mexico. And let's see, next slide. It's not changing. Why is my slide not changing? Huh. Next slide. Okay, got it. So this is the problem. For every barrel of oil that comes out of the ground, 4 to 8 barrels of toxic wastewater come along with it. And this water is called produced water. And what the oil companies do is they just get rid of it as soon as they can. And this is pumping it underground in Texas or chemically treating it and storing it above ground in New Mexico. Those are the #1 and #2 oil producing regions in America. This is a waste of water and a waste of money. It's not a sustainable option, and it causes earthquakes. Texas experienced last year the largest number of earthquakes outside of California because of their underground water disposal. We have the solution, and that's Undesert's SWAP water purification device, which you see a picture of what we envision here. SWAP can process wastewater for $1 per barrel using our proprietary device. And one device can process 500 barrels every single day, and taking that water to perfectly pure distilled water, actually, that can be used for agriculture and other forestry or agriculture applications. We're currently partnered with the state of New Mexico to demonstrate this. We ran the Shell Game Changer program through that accelerator last year, and we're working with a produced water disposal company called Martin Water. I'm the CEO. I built a tech company called Auditude from 0 to 50 people before I sold it to Adobe Corporation in 2011. I did an undergrad Harvey Mudd double major engineering economics and a UCLA MBA. My co-founder Hill is the tech guy. He's the tech genius. He served actually in the Texas legislature, but of course before that he was a petrochemical engineer in the industry for 4 decades. So he's the inventor and patent holder of our technology. We're also joined by a great bunch of advisors across industry and academia. Most recently, Morris Clark, the CFO of Marathon Oil, joined our board. We participated in Techstars. We are in the top 10% in the Elon Musk $100 million X Prize, which is announced next year, and have been looking forward to planting a big forest in the desert to show that we can do it. We've demonstrated our technology in the Middle East, in the United Arab Emirates, taking a raw calcic horizon into a farm, basically, for fruits and vegetables. The technology is, we have 2 issued patents, so it is protected. It is very low energy. And that's really the key differentiator, is that we can perform this very complex desalination process without using too much raw energy input. In fact, it used to be powered just with solar panels. Now we use waste energy that is easily accessible on the oil field. In terms of our competition, there really isn't any, because if you look at the state of the art, reverse osmosis kind of taps out at 2x seawater, and produced water is at 4x. That's why they pump it underground. But you know what? That causes earthquakes. We're looking for $2 million as a pre-seed to get to manufacturing. And if we can forest the world's deserts, 1% is all it takes to stop global warming in its tracks. And we're talking about desertified land around oil pipelines. There's a ton of it, and we can clean it up. And that's it.
Great. Thank you so much. And within 5 minutes, perfect. So with that, we'll open the floor to questions. So if anybody has a question, please raise your hand and we'll get the ball rolling with Nicholas. Richard.
Thanks, Nicholas. Enjoyed the presentation. Can you, maybe you don't want to talk about it at this point. So the IP, can you say a little bit about the technology side of this?
Yeah, so initially what my co-founder did was he was very set on working here in the United Arab Emirates, and they have a ton of sun and land. So he built a solar version of the device initially, and that's what he filed his initial 2 patents on a decade ago. And those were issued, and those are the 2 patents that protect the core. What we did at the Shell Game Changer is Shell said, we're based in Louisiana. We don't have any good solar energy source. We need something that can handle our very high, and the hundreds of thousands of barrels of capacity per day, which our solar device was not at that scale. So we worked with Shell Corporation to now build this device that's inside of that shipping container that I showed earlier. One device can process 500 barrels per 24 hours, only requiring minimal energy input. We're actually half the energy of reverse osmosis. And that's actually a breakthrough in this water desalination field, such that we can scale. My dream is to have a couple of our swap units beside each water oil drilling site, so that we can actually process this produced water as it comes out of the ground, as they've skimmed off the oil, and then we can then forest around these pipelines by default, because it's right there. It's no transportation cost.
Thank you.
Great. We have Paz here also with his hand raised.
Nicholas, I just want to ask, this is a great product, great vision. What are the raw materials used on the input side, and what are the waste products that come out of it?
Yeah, no, absolutely. So this is, we take the water from very high, where's my thermometer slide? Very high ppm salt, so very concentrated. And we took it to distilled water, which is like sub 5 parts per million salt. So it's actually too pure to drink, right? It's distilled water. And then the waste stream is extremely high ppm salt. And what that is, that waste brine, as our previous presenter said, it's very mineral rich. So yeah, you could mine it for lithium and so forth. But in the desert application, you can sequester that salt in a permanent structure just by drying it out in the sun. It'll dry out a millimeter at a time, and then over 6 months, you can just turn it into a brick, a salt brick, that literally you could stucco the outside and use it for construction material. So as we imagine a world where there is decreasing locations to live, you could have forests in the desert with construction material locally provided to build these salt structures, which is another resource for the displaced millions that are coming.
Thank you.
Yeah.
Great. And we have another question from Lynn.
Hey, a quick question here. I may have missed where you said it, but what's the current TRL level and sort of years to actual
So we
production?
are
Yeah.
actually at a TRL 7. So this device, the prototype exists or is close to existing in a demo environment, so that we are going to be locating our device at the produced water disposal site, which right now that wastewater is being dumped into a pond and evaporated. So what we're going to do is to take that produced water and process it and demonstrate it at a commercial scale. So that once we raise a pre-seed, we were able to take that demo and go to manufacturing, and that's what the pre-seed is for.
And then
Yeah.
just timeline on that.
So the next 6 months. So next few
Okay.
months we'll do this demo, and then we'll be ready to rock and roll.
Cool. Thank you.
You're welcome.
All right, great. So that's actually all the time we have. But thank you so much, Nicholas. Please put your contact info in the chat if you want people to reach out if they
I
have
will
any
do
more
that.
questions. And with that, we'll move on to our next presentation, which is Jewel Case.
Should be able to see my screen.
Yes, we could see it.
Great. Okay. Yeah, so Jewel Case has developed and is delivering an intelligent power platform that economically replaces diesel generators in massive portable markets. With $5 million booked in 2023 and already over $2 million in 2024, we've delivered thousands of our systems to customers like Eaton, United Rentals, Air Force, Live Nation, Department of Defense, and NASA. And we've been featured in Fast Company and TechCrunch. And we've been very capital efficient, having delivered our patents, our products, and now scaling revenue with just $8 million raised. And we started R&D in 2015. So this has allowed us to file the key blocking patents, with 13 patents already granted and many more pending across the portable power ecosystem. And this patent portfolio and this traction has allowed us to hire top-tier talent from Mercedes-Benz, IBM, and even Apple's head of battery. So in summary, Jewel Case has developed a portable power platform to replace large diesel generators, and the market has responded with accelerating revenue growth. So here's a look at our broad-based power platform. Our secret sauce is our patented bidirectional DC-DC converter, coupled with our intelligent control module and software. So we don't build the battery, but we put the brains in the battery. So it doesn't matter the size of the battery, the state of charge, or even the battery chemistry. All of these integrate and work together. So customers can use this scalable intelligent power with plug-and-play functionality, utilizing our intelligent control module that's energy source agnostic for whatever their large portable power need is. So you don't need to be an electrician or an electrical engineer to work. It simply works for you. And when you've developed a platform like this that can pull from the grid, from renewables, from diesel generators, packages in different form factors, move this around and deploy to different use cases, such as site power, transportation, radar trucks, whatever you might need, what you've done is you created that platform that can quickly accelerate electrification and clean energy uses to eliminate these diesel generators. And here's the world-class team that's making this happen. Alex Livingston and I are on our second battery startup together with over 15 years of application-focused modular battery technologies. We've been able to poach Apple's head of battery to become our CTO, Dave DeMuro. He's one of the foremost lithium-ion battery experts in North America, being the engineer that unveiled the Motorola Microtel lithium-ion battery phone originally. And then he built up the internal battery team at Apple, where his battery designs are in billions of products worldwide. The rest of our executive team come to us from IBM, Oracle, Mercedes-Benz, bodybuilding.com, and even Tesla as well. And so Jewel Case is patented. And so we have 3 granted patents on our advanced battery management system, 2 patents on our grid scale portable battery system, 4 patents on that key architecture feature of separating the power from the energy, and even patents that have been granted to extend into the consumer markets. So one of these patents I like to feature is our modularized ESS and power distribution system. So this patent really is kind of that figure that I showed before, where you can pull power from different use cases, move it around and deploy it in other unique use cases to have just the perfect amount of power for each one, no matter the voltage, the charge characteristics, whatever you need. This makes it so it's all very seamless and easy for that customer. And so having developed that platform, there are many customers who are coming to us with their portable power needs. And so 3 verticals that we are serving right now are site power. So think of construction sites, forward operating bases, natural disaster, portable or even kind of fixed EV charging, and even small portable power such as work trucks and food trucks are all using Joule Case for their power needs. And so one of these customers I like to feature is the Department of Defense. So far, they've already purchased over $3 million buying across the entire Joule Case platform. Applications include ISR, both CONUS and OCONUS, a joint Army Air Force project powering Frankensam that are both dual use aviation and GPU, and then also food service and drink service on base as well. Another customer is the Washington, D.C. Department of Transportation, who is using Joule Case for their level 3 DC fast charging for their fleet of electric buses. So this is about $1 million a year for the next 5 years to supplement their on-grid services to make it so that they can make sure all of their buses are charged overnight and ready for the next day. And then finally, in the work truck, food truck space, Joule Case is the leader in the space, having installed into hundreds of work trucks nationwide, where these businesses are trusting their critical power needs to Joule Case. And if you look at the different power applications, there are other fixed systems, but Joule Case is able to size and scale from anything from a level 3 DC fast charging all the way down to integrating within a work truck. So that modularity is really the key to our space. So unlike some of these fixed trailer systems, Joule Case can bridge to be much smaller and larger, and you can ideally size for each one of these applications. You know, batteries are very expensive, so you need to make sure that that is ideally sized every time, and small little changes in that application. It could be, you know, a couple more hours or a couple additional applications suddenly will change how much power you really need. And that really leverages our technology. And then so we're building a syndicate that already includes one of the largest fund of funds, a number of CVCs, and participation from large family offices, and are looking for one or more institutional investors to tie the round together. And thank you for your time today, and happy to answer any questions.
Great, thank you so much, James. That was great. Open the floor to questions. So if anybody has a question, just raise your
James.
hand.
Oh, hey, Brian, it's Javier. James, is this just one big rechargeable battery?
No, this is multiple different sizes of batteries. But what customers come to us, and like what the military has come to us for, and let me try to get back to that page, is that there are specific power needs that are needed. And because we are so flexible in how we can solve for that, we can quickly come up with a configurable solution that serves their needs ideally. And then so, the Department of Defense has come to us with various different power needs, and we can, it's not an engineering problem anymore. It's a quickly, kind of a sales problem to be able to solve for this. So, these ISR applications or the Frankensam project, we got a solution to them very quickly.
Is there a standard battery that you use? Like, is this like the batteries for Teslas? Is that the kind of battery that underlie, like, that if you open these boxes up, that's what we're going to find inside?
Yeah, so we use, currently we use lithium iron phosphate and NMC. So those are both lithium battery chemistries, but we've already transitioned the chemistry quite a bit. So it doesn't really matter the chemistry. And as you start to look at like maybe sodium batteries and, there's a whole bunch, I've been in space for over a decade. There's always a next promising battery chemistry. But the billions of dollars being put into the chemistry can be packaged and leveraged within our platform. So the end user, the Department of Defense, doesn't need to be worried about a chemistry. They just know that all of this works together, and we are forward and backward compatible, so that they have an old system that is maybe NMC. It can integrate with a new system that may be a different chemistry.
Thanks, James.
Time for another question, if anybody has any.
I got one. So you don't make the cells, you're neutral or agnostic as to what the cell chemistry is. This is a next generation module that includes the BMS battery management system, the charging system, and the DC to AC inverter, all in one box with some additional smarts that represent your IP.
Broadly, yes, right? So it's not about the battery, and we don't want to build up another battery factory. What we're doing is controlling the batteries in a way to make it so that it's very accessible and elegant and simple for the customer, right? And so that includes our control system, our bidirectional DC converters, our own proprietary battery management system as well.
I think there's a space for this.
Yeah. Yeah, thank you.
Great. So if nobody has any other questions, James, you can leave your contact info in the chat, and then people who want to reach out, talk to you later, could do so. But it was a great presentation, and thank you so much.
Yep. Thank you.
And with that, we will move on to our next presentation, which is POE Texas. And let me just see if I could optimize this for, or maybe, I don't know, Tyler, is there a way for you when you click on share screen where there's an option for optimizing for video clip?
Let me double check. Oh, there we go. I've got it optimized for video clip. It is not letting me do it.
Okay, here, let me just try to, let me stop your sharing. I'll just share something on my end to see if that will work. I optimize on my end. Huh, not even letting me do that. Let me. Okay. That's pretty odd. So what we could do is if when you're sharing and you want to share your video, there is an advanced tab and there is something for video that you could try to click, and hopefully that'll work.
Okay, we'll give it a shot. Let me know. We've got an early one here to test the audio. Let me know if, so I'll just go ahead and dive in if that's all right, Brian. I'll give a little bit of background about myself. My name is Tyler Andrews. I'm the CEO of POE Texas. For almost 20 years, I built complex, highly technical projects all over the world, from Korea to Calgary for ExxonMobil and iFly. iFly is a small indoor skydiving wind tunnel that grew from 6 people to thousands of people. And when they went through the Series B investment round, they bought up all of the shares, including mine. And ironically, that meant I had a problem. I had a little nest egg to invest, but I wasn't ready to just sit at home. Actually, if I'm being really honest, my wife wasn't ready for me to just sit around at home. So I needed to figure out where to invest to get the best growth for the next 20 years. So while I was looking around to invest, a friend introduced me to someone running a small POE technology company here in Austin, Texas. And when he showed me what they could do with Power over Ethernet, my mind was blown. Here's basically how the due diligence went on the investment. POE was first sold in the year 2000 for VoIP phones, and then it became the standard for wireless access point, and then it became the standard for security cameras. And then over the past 24 years, it has become the de facto standard for converging smart building technology. So before I go any further, let me answer the question, what is Power over Ethernet, or PoE? Is my audio coming through on this?
No, I'm not hearing anything.
Not the video audio.
No video audio? Okay. Let me see if I can get the audio to come through. It's looking like it's not liking sharing the audio, so I'm going to try and flip to my backup plan B. Let me do that real quick. going to turn off my camera so I can see if I can switch my camera to show it on my video screen rather than me talking directly. We'll give this about 2 seconds and then I'll move forward.
We could faintly hear it.
Sorry, are you able to hear it?
Very faintly.
All right, well, teach me to have a video ready for a showcase. It's not still playing, is it, Brian?
No, we're not getting audio.
Okay.
When you share, when you share your screen, there's a checkbox that says share audio also. You have to do that if you're for the one that's on, you're trying to share video here. I don't know if you did that.
Yeah, that's the challenge that Brian and I are running into, is it's not letting us share. Let's see if I can share my computer audio. Here we go. Let's see if this will share. And I apologize about the delay on this.
Yeah, we don't really hear. Somebody also just noted that when you're sharing screen, you have to check the box, enable audio or something similar. You have to stop this share and then start again. So we could try that. Doesn't work, doesn't work.
We'll try one more time.
Yeah.
I'm still not getting the option to share my audio. All right, we'll move forward without the video. And I apologize about the delay on that. So, quick update on what POE is. And maybe I'll narrate the video. All right. Power over Ethernet is the ability to combine both power and data onto the same network cable. And that power allows you to connect things like VoIP phones, and that power and data has a unique ability to drive phones, cameras, PCs, and now what's exciting is that the power is starting to grow and allow you to do other things. But what's most important is power over Ethernet is the same globally wherever you are in the world, whether you're in Tulsa or Tokyo. PoE is the only universally accepted power standard. Obviously, I'm catching up on the video. Now, what the power of Power over Ethernet is, or what's unique about it, is that because we're combining power and data onto a single cable, we use 60% less copper, and because it's touch-safe technology, it doesn't require conduit. It makes it the most efficient, most carbon-friendly version for sending power and data, especially in applications where you want to be able to do controls, in particular lighting, automation. The other power of Power over Ethernet is that it is touch-safe technology. It's Class 2 in the National Electrical Code, allowing you to use Power over Ethernet in any application, whether you have a licensed electrician or whether you want to do it directly. And our studies have shown over the past 5 years that PoE saves 30% on average over doing work traditionally with normal technology. This is allowing us to really expand the ability of what automation and lighting can do. You can do check-in kiosks, displays, point-of-sale stations. In particular, we're upgrading classrooms with power and data to student laptops with our patented USB-C, PoE USB-C technology, and the new advancements are PoE lighting and automation with shades and blinds. So this is where Power over Ethernet is really growing and developing over the next few years. So why is this important? If you would have asked me 5 years ago or 6 years ago when I bought POE Texas, where would be the safest and best place to invest money in technology that I knew would grow, I'd say to look where the technology has been converging for the past 10 to 20 years and invest there. And what is converging? Converging technology in the smart building space is Power over Ethernet. It's where lights, access control, security, all the different technologies that make up smart buildings are going to Power over Ethernet. And that's really the value of the technology. Let me wrap it up. So POE Texas is presenting today looking for 3 opportunities. Owners and developers who are looking to differentiate themselves through technology with advanced amenities. Contractors interested in seeing improved margins and recurring revenue opportunities. And a potential strategic partnership or investment to help us grow through an acquisition-based business model. We are a profitable company. We have been profitable for the last 6 years. Our products are being used worldwide right now, and we are ready to take this to the next step through an infusion of capital and opportunities. Thank you very much.
All right, thank you, Tyler. So opening the floor to questions. If anybody has a question, just raise your hand. We'll get the ball rolling. I don't recall if this was covered. I'll just jump in with the first one while others are thinking of a question. But I don't know if this was covered. But did you mention how much, say, materials you would save, such as like copper, relative to the current power infrastructure?
We did, but I'm happy to bring that up and show the slide on the screen what that looks like. Pull it up here. It is 60% less copper and 100% less steel conduit, making it 30% less on cost. And so the CapEx is 30%, and it reduces the carbon footprint.
And are you also looking for opportunities in, aside from investment, such as in the DoD?
Yes, thank you very much. Yes, we are looking for opportunities with the DoD. We've been working with Brent and his team on an MOU for a phase 2 for AFWERX. We're ready to migrate this commercially available technology to be available for DoD and military applications.
Awesome. We do have time for another question if anybody has any.
Do you see any appliances working on PoE other than lighting? Stereo systems,
Great
TVs that could run on 48 volts and 600 milliamps?
Great question. Yes. TV, displays, shades, curtains. There are a whole wide range of products that are migrating to PoE right now. I know people have been doing refrigerators, Power over Ethernet. And I do know of a few manufacturers who are working on a PoE-enabled mini split unit for an AC unit.
Awesome. Awesome. So unfortunately, that's all the time we have. But thank you so much, Tyler. That was great. And be sure to leave your contact info in the chat so that people could reach out. Maybe they're taking some time to formulate the questions in their head, and then by the time they think of it, they'll be able to reach out and connect. And with that, we'll move on to our next presentation, which is 247 Solar, and we have Bruce here to present for that.
Good afternoon, everybody. Let me get my presentation up. I'm Bruce Anderson, the CEO of 247 Solar, one of the inventors of our system. The problem is that well, what we do is sell electricity and heat around the clock. And the problem is, of course, everything from resiliency to reliability, and with all of the intermittent clean energy, I don't know why that's going by itself. Wind and solar only operate some of the time, but our system operates every hour of the day, even during bad weather. We use our proprietary technologies. We have 30 patents, MIT origins, and we design, build, operate, and sell the electricity and heat round the clock, 24 hours a day, to industrial and utility customers, and including government and DoD. One of our breakthrough technologies converts sunlight to heat instead of electricity. Now, this is a big advantage because we can store a lot of heat for a long period of time at a low cost. And another technology converts that heat into electricity without any combustion or emissions. And all this whole entire system is just ambient pressure, hot air. Very, very simple system. One of our sales was to India's largest utility companies. They use coal for round-the-clock power. We have these sun tracking mirrors in the ground that reflect their light up on top of the tower. And then that first proprietary technology converts it to heat at 1800 degrees. It heats the air. And some of that air comes down and powers our turbine, which I mentioned. And half of it roughly goes to our thermal energy storage system. Here's our lower sunshine solution. Here, electricity from wind and PV heat the storage system, and then the storage system powers the turbine sitting here. And this substitutes for the diesel gensets and provides us heat and power 24 hours a day. The returns are phenomenal. So, like I said, we do build, own, operate, and sell the power. And we do that because we have a finance partner investing half $1 billion into our 24/7 solar capital fund. This fund in turn forms special project vehicles for each customer. And then we sell the energy to the customer. So we will also sell the systems, but we prefer to sell the power. The markets for this are huge. And for the government, being able to increase your resiliency, the reliability of your energy infrastructure while reducing your carbon emissions and reducing your bills could be very attractive to you. In just our first year of sales, we registered $3 million. And our pipeline is huge. People love this technology because it's so simple and it operates 24/7. We are projecting very high growth. And we think these projections to $1 billion in just a few years are actually conservative, particularly since we don't rely on the customer to buy the system. We have several sources of revenue. We have the recurring energy sales, of course, the system sales. We license our technology in certain situations. And of course, like all power generation equipment, they require after-sales parts and services. We have a great team. It's really seasoned. We have several people from MIT, including myself, over 115 years of experience in this industry. We've raised $22 million to develop the technology. And now we've raised $8 million. We're about to close our Series A round to commercialize. We'll install our first sales and book an additional $50 million in sales. Thank you. I welcome your questions.
All right. Thank you so much. So we have a question from Spandan.
Yeah, hi.
I've got a couple of questions. Go ahead. I'm
from BDF Ventures, and I'm also from India. That's why I can ask this question.
Yeah.
I think the technology or the infrastructure behind converting the heat to electricity is fairly matured, and with a lot of batteries and battery companies operating there. How are you positioning like efficiency gains or capital gains with this technology? Because you'll be going head to head against those companies. What's your defensive mode there?
Well, we don't have a defensive mode. Ours is offensive. The cost of our storage is a fraction of the cost of batteries. And we operate 24/7. Even PV plus batteries requires a backup. And that's the frustrating part of our current energy transition, is that we're putting tons of intermittent energy on the grid, lots of batteries, but then there's no backup when we have bad weather. This is a complete 24-hour-a-day solution.
Thank you.
So I had a couple of questions. What is the thermal storage medium? Is it liquid salt or propylene glycol? What is it?
No way, no way. No environmental issues associated with this system. No water, no molten salts, no high temperature fluids, no steam. These are gas turbines like jet engines. And our storage system is small pieces of ceramic, shipping container size units filled with small pieces of ceramic, and we circulate the air through them. The only moving parts in our system are blowers and dampers.
So the heat is stored in the ceramic, and the medium is hot air, not steam, into the genset.
Correct. Our storage system has a life of at least 40 years with virtually no maintenance, no moving parts, nothing to wear out, nothing to hurt the environment, recyclable.
Okay, that's interesting. I'd call this next generation CSP. It's different.
Yeah, we think so
You got
too.
something.
We have ideas for to take this to yet another generation.
And well, last question, what is the mirror system, what is the land use? How many acres per megawatt would be a measure?
It's about 12 acres per megawatt. And when we use the heat as well as the electricity, we harvest about 2.25 times more energy per acre compared with PV.
So 3 times the land use, but 2.5 times the overall heat or energy recovery. So it's similar.
Similar in land area, but more efficient, yes. More efficient land area.
Okay, thank you, Bruce. What is your
Yeah.
ask? What are you looking for?
Well, we have this $8 million round that we're closing, but we're giving interested people another month to join us and blow through that $8 million round. This is the kind of business, Dan, where the more capital you have, the faster you can grow. We have an 18-month runway right now. We're limiting our growth to maintain that runway for the time being, and we'd love to grow faster, and that's what more capital will give us.
What's the smallest size system that is economically viable?
400 kilowatts.
Really? Tiny.
And we have a 2 megawatt and 5 megawatt system on the drawing boards.
Okay. I don't know if you saw my presentation an hour ago, but I was planning 15 megawatts of solar PV. Maybe I should take a closer look at 24/7 solar.
Happy to engage with you, Dan. We're also looking, of course, for customers.
Great. So if anybody has another question, feel free to ask. I'll give the 5 more seconds. If anybody has any, raise your hand. Ask a question to Bruce. But if not, Bruce, thank you so much
Yeah,
for your
thanks for the
presentation.
opportunity. I really appreciate it.
Sure. I appreciate your presentation, and feel free to put your contact info in the chat. so that people could know where to reach you after you're done presenting. If they want to connect, learn more, or anything else. So with that, we will move on to our next presentation, which is Runwise, and we have Lee here to present.
Hello, everybody. Let me present my screen. Get started. All right. Awesome. So hello, everybody. My name is Lee Hoffman. I'm one of the co-founders of Runwise. To give a little background on me, I come from a heavy tech startup background. I've been building companies for the better part of 20 plus years. Had a couple of exits. My last company was randomly in the wedding tech space and sold to the country's largest wedding company, The Knot. My co-founder Jeff comes from the real estate side, and the business got started because Jeff was really, he was running 150 multifamily buildings. And this is a very adorable photo of Jeff, myself, and our third co-founder, Mike. We like to pose in front of graffiti because, it makes us look better. Jeff was running 150 multifamily buildings in the city for a single owner for about 10 years. And there was no sophisticated, analysis of what was happening with energy. Jeff was literally just hitting pay on the energy bills and would notice that one building would be using 60, 70, 80% more energy per square foot. And that just didn't make sense to him. He worked for one of the most, financially conservative real estate landlords in New York City, who was on top of literally every cent in their organization and in their buildings. And when Jeff did a back of the envelope analysis of the energy usage, he realized that if all of the buildings had simply run as well as the top 25%, they would have saved something like $7 million each year. So it's just a gigantic amount of energy waste. And, that's when he started to see there was a problem. He came to me and we started really looking into what was going on. And what we figured out is that the vast majority of buildings, not only in New York City, but pretty much in the entire country, are running on control infrastructure that really hasn't changed since the 1960s and 1970s. I give this classic example of, we were in a building a few weeks ago. It was a brand new building in New York City, high-rise glass building, glass facade. It has a LEED sticker on the door. You think this is the most energy efficient building ever made. It's only 2 years old. And you go to the HVAC floor and the controls controlling several $1 million of cooling and heating. Number one, the software is hard coded onto them, so they're never going to get smarter. Like your iPhone gets updates every day. These controls are running what's known as an outdoor reset algorithm, which is literally just a hard coded table of how many minutes to run with the temp based on the temperature outside. They have no sensors in the building, so they have no idea what's happening in the building whatsoever. And they're in most cases not connected to the internet. So this is what's running something like 99% of buildings in the country. It's incredibly wasteful, tons of money out the door. Also, a huge, huge portion of the carbon output in this country are coming from this waste. And I think what Jeff really intuited early on was, if you want to change how 12 million buildings in the United States are operating on these legacy controls, we really have to make it something that is not paid back in years within our life, 2, 3, 4, 5 years, but something that it pays for itself in a number of months. And that's really what we did. We basically took what traditional control companies might sell and would require miles of wiring and people on ladders and electricians 2 to 3 weeks to install this physical control layer. And we turned it into something that's completely wireless and generally can be installed in 1 day or less. And once it's installed, everything runs on 10-year battery life, meaning we install it, nobody has to come back for 10 years, nobody has to manage it, nobody has to change batteries, nothing for 10 years. What this effectively does is it substantially lowers the cost and time of replacing this infrastructure and buildings, this control infrastructure, by a factor of 20 or 30. And since you're essentially lowering the cost dramatically, once we put sensors and smart software into buildings, we can then run these buildings much more energy efficiently. The net result is that we can lower energy costs by about 20 to 25%, and the system will pay for itself in a handful of months. As a byproduct of that, you also get to run your buildings on your iPhone or your Android, detect problems in real time before tenants or other people can get injured, before you waste a lot of money, and it just makes running the building a lot easier. But all of that comes free out of both the financial savings and the carbon savings, which are pretty incredible. And so this secret sauce of essentially giving a financial incentive, carbon incentive, and management incentive to owners is really what's gotten us to scale. We're now in 7,500 buildings. We do hundreds of pretty much all of the top owners in the country, from Related, Equity Residential, Element, Blackstone. We do MTA buildings, LIR, NJT buildings. If there's a building in a large company out there, or even small mom and pops, there's a good chance that we're running some or all of their buildings already substantially more energy efficiently. And to put this into real world carbon impact, this is not theoretical. We actually have every single energy bill from all of our buildings. So we calculate to the therm how much energy is being reduced across those 7,500 buildings. In the last year, we reduced fossil fuel usage by about 21.2%. So this is just transformational amount of carbon reduction that's happening at scale already. And we're more than doubling every single year moving forward. To give you a scale of where this is going, we started with just running heating systems more efficiently. Last year, we launched water. We find all the running toilets in buildings, huge amount of carbon and economic waste. And soon we're moving to electric cooling, electrification, demand response, and ultimately an open platform for running buildings in general to make it really easy to use the low cost, fast to install wireless chipset and network that's already installed in thousands, tens of thousands of buildings to run any application, to run anything in a building more energy efficiently. And the reason that this is critical, you know, we all think of, okay, carbon comes from cars, right? So like Tesla is going to save the planet. But in reality, somewhere between 28 and 40% of carbon emissions in basically any city like New York, Chicago, LA, comes from how buildings operate. So if you want to address the climate issue, there literally is no way to do it other than to start with how buildings operate. And really, we've just found sort of the secret sauce to incentivize owners and operators to do that at scale. So I'll end it there and turn it over to questions if anybody has any.
Awesome. That's a great presentation. Yeah, so open the floor to questions, and we have one ready from Lisa.
Hey, Lisa, how you doing?
Good, how are
Nice to
you?
meet you.
Super cool. So do you have to integrate with a system, these management systems that are in buildings today? Did you have to gain access? You know, how did you sort of navigate that with all the different building management control systems around?
So we work with buildings that do have BMSs already installed and systems that don't. We all think of like buildings like, oh, they're all the like, you know, the Empire State Building or something, but actually the vast majority of buildings in the United States are not gigantic buildings, they're small buildings. And if you go to New York, you just walk down the street, you'll see 50 tiny little buildings for every one giant building, right? So something like 93, 94% of buildings have no BMS system installed. So we're fine with that. We will put our wireless network in our control. We can take control of everything, no problem. If there is a BMS system, that's great too. We're happy to connect to it. We will take control of the various systems that we need to run more efficiently. We take ownership of running them, and we'll play nicely with the BMS that's there. We're not trying to replace or throw any technology that's already out. We really just want to make running buildings much more easy and take control of systems where we know we can save a ton of energy by running them better and more efficiently.
So it seems like a no-brainer. I mean, why wouldn't people want a system like this? What are you hearing?
It's really just, no, it's really just attention. You know, you're a property manager or owner, you have a million things going on. You have a refinance that's happening in building X. You have the ceiling fell in building Y. You're trying to fill 12 leases. And somebody comes along and is like, we'll save you a bunch of energy. And they're like, yeah, I've heard that pitch a million times, right? So it's just getting people's attention. The way we've typically broken through is we go to an owner operator, we somehow get them to listen to us for 5 minutes. And then we say to them, hey, look, give us 2 or 3 buildings. Here's what the financials are going to look like. In fact, we're going to guarantee you're going to make your money back in 5 months. We're going to put it in the contract. If you don't like the sound of my voice after 5 months, whatever it is, we'll give your money back 100%. It's in the contract. You have zero risk. oh, and by the way, your utility is probably going to pay for 100% of this, so you don't even have to put in money down. And we just try to basically make it as low transaction, oriented to get them to just put it in 2 or 3 buildings. And then once they see the results in 2 or 3 buildings, we have nearly 100% upsell rate to get to the rest of the portfolio. And that's sort of what we've historically done.
And then just one more question. I know New York has a program, right, for energy efficiency. I can't remember the name of it. Is that a driver for you? And do other big cities across the country have something similar that helps to educate building owners about technology like this?
Yeah, there are two different things that are happening at once that I think are definitely been helpful. One is most of the utility companies in the country have a mandate by the state, by their state, to offer rebates for energy efficiency measures that have proven to be high ROI, low cost measures to drive down carbon reduction. So we've been very lucky to be able to prove those results at a large enough scale that almost all utilities in our areas are offering pretty generous rebates to cover the cost of Runwise. So that's definitely super helpful because it just makes it easier to make the decision, right? If you don't have to put much money down. The second is that most cities have been passing climate laws. So in New York, it's Local Law 97, and Massachusetts, it's BERDO, basically essentially requiring carbon reduction. In most of those cities, smart controls like what we offer are essentially required at this point if you want to hit your thresholds. So that also has been helpful because, again, even if somebody, they inherited a building, they don't really want to think about it, they refi every 30 years, and they don't want to put any effort in, they're basically being forced now to pay attention and do the thing they should have done, which is to, make their building run more economically efficiently and as a byproduct, more carbon efficiently.
Thank you.
All right, great. We do have a question in the chat actually, is how did you calculate the carbon savings? And what is your local Law 94 impact on reducing fines?
Yeah, so we calculate carbon savings because we use the fuel bills. So we usually get a year of fuel bills prior to install, and then we get every single fuel bill after for every one of the buildings that goes on the system. So if it's burning oil, we know how many gallons of oil it was using before and after. If it's gas, we know how many therms. And then we simply adjust for weather using the industry standard degree days. And that can tell us precisely how many therms or gallons we've saved every month and year moving forward. And that's a very easy calculation to turn into MBTU or any type of carbon calculation that you want. For Local Law 97, different cities have different mandates, but I'll give you Local Law 97 in New York as the example. Typically, if you install Runwise, it will put you where you need to be through certainly 2025 and in many cases 2030. If you do 1 or 2 other measures, usually a downsizing of a boiler, or you can do hot water heaters for the summer and Runwise, that'll usually get you through 2035.
Awesome. Well, that sounds really great. And that's all the time we have, unfortunately. But thank you so much, Lee. It was a great presentation. And please put your contact info in the chat so people can reach out to you after. I'm sure some people will want to. And up next, we have our penultimate presentation. We have Rebuild, and we have Paul here to present on their behalf. And you're muted, Paul.
Can you hear me okay? And can you see my screen?
Yeah, we can hear you and see your screen.
Great, thank you. I'm Paul Bollier from Rebuild Manufacturing. Thank you for this opportunity. I'll take you through some of the background on Rebuild Manufacturing, describe the origins of our company, our mission, and what we're doing and how we're serving clients. In particular, the focus of this presentation will be some case studies where we've helped early stage companies in a variety of areas achieve some important proof points on their technology, as well as their ability to scale up, to demonstrate commercialization success, and to help them move forward with their business plans, with raising money, et cetera. Over to the next slide. I'm going to show it this way, if you can still see it, and we'll do it this way. Can you see my second slide?
Yes.
Okay. Rebuild Manufacturing is a company that was founded in 2020 with an idea and a vision that there are attractive opportunities, interesting opportunities to apply advanced manufacturing technologies and engineering design services to help companies compete on a global scale with more automation, with, again, applying some material science know-how and some fundamental good practices with engineering services. If you look at you can look online and learn more about us and who's behind us. There's several people from our leadership group that are from MIT, and we have a strong relationship with MIT. And as I say, several of our team leaders are from MIT. We've acquired a total of 11 companies, and we work together in what we describe as a collaborative and intensely collaborative way to help our clients scale up. Today, we'll focus particularly on energy and energy-related applications, but we do work in a lot of other areas as well. In terms of our solutions and services, again, we work with early-stage companies, some late-stage companies, large companies as well. A lot of it has to do with basically applying automation and engineering design services for particularly challenging engineering problems or projects or opportunities. And we also do a lot of work with what we'll call advanced data analytics and data science tools. In particular, as it relates to the work that we've done in energy and in batteries and energy storage, we've done a lot of work on material science and we have some deep experience there. You see some of the materials that we've worked with. It's a variety of materials you would often see in electronic applications and energy storage applications. And you also see the methods and the applications that we use using some of those materials. Regarding automation, as I mentioned, I'll continue to mention throughout, it's a key capability that we look to employ, again, to help companies compete on a global scale. And we'll talk about some of those in the case studies as well. Precise pick and place, a lot of work with test equipment to help accelerate R&D programs, et cetera. So if we look at our first case study, it has to do with commercializing what we'll call a novel processing technology for battery electrode materials. An inventor came to us as a plasma physicist who had a prototype reactor and had some concerns about the safety of it and how to scale it up, make it more robust so that he could work on it and develop some processes around it. We developed his first alpha machine. We designed it and sourced it, procured the components. In that case, he built it himself. And that helped the inventor to raise some grant money. He came back 4 years later and re-engaged us for design and manufacturing. During the process of that project, he pivoted his business model from selling equipment to selling materials. And so we helped him facilitate that equipment in a safe way. And we built and commissioned his several tools for him, subsequently raised successful Series A. And then a couple of years after that, re-engaged again because the inventor had some ideas about how to apply this particular technology for processing battery-related materials. So we're involved in process development, material handling systems, and they subsequently had a very successful Series C and D where they raised over $150 million. In the second case study, we worked with we'll call it a novel energy storage technology. Again, there's some similar attributes here as the first case study. We're approached by a group of engineers who had worked together in a research lab. They had a novel energy cell and they needed some help on how to scale it up to a larger area. And they at the time didn't have any experience commercializing any technologies. They had grant money to get started. We were engaged to do what we call a techno-economic study to evaluate various trade-offs and in terms of approaches, material choices, and what we call material performance versus economic viability. And that again helped the client to raise additional grant money. And then after that, they engaged us for an alpha unit where we designed and built an alpha unit and helped them raise a Series A. Later, helped them work with a beta unit as well. And there were some particular challenges in that particular system that I'll highlight as one of our capabilities. And that's working with high heat environments, high heat materials, and you'll see that in some of the additional case studies as well, and some of the things that we offer. But in this case, again, this sequence resulted in the client raising a successful Series B. And the last one, I'll go relatively quickly through it. This was a company, kind of an interesting challenge. Their science was they were confident in their science in terms of their science for hydrogen fuel cell technology, but they were having problems with breaking their test specimens as they were trying to test them. It was a particularly fragile material, and it was also a difficult material to automate because it was porous. And so we took it on. There were some other the internal groups and other firms had worked on this, but were unable to find a solution that would able to semi-automate this process in a way that didn't damage the specimens. And so we applied some lessons that we had learned and some tools and approaches that we were aware of from what we'll call a parallel industry, and delivered a damage-free high-speed tool and process. And it did help them accelerate their R&D, and that company ended up being acquired shortly thereafter. This is an interesting one because we work on fundamental science, deep tech problems as well, but this is one where it was, in more of a tactical approach to how to help them accelerate their R&D with some advanced tools. We have a lot of other case studies across the energy spectrum, hydrogen, fuel cell test stands, et cetera, which we're happy to talk to you about if you're curious to learn more. We have a particular deep focus on both solar and battery manufacturing. I'll highlight some of the things we do in the solar industry now. It's typically upstream. We've heard many of the presenters today talk about things that are happening on the module side or on the concentrated photovoltaic side. And that's an area where we also do some work, but our primary focus at this point is on the upstream side. And it gets back to some of our fundamental capabilities in crystal growth, high temperature processes, et cetera. The vast majority of solar photovoltaics are built upon silicon wafers, and it's important to start with high quality crystalline silicon. And so there are many parameters that need to be managed very carefully, particularly in a high volume, low cost environment. And that's an area where we're working with several clients today. A key part of that is the work we do on what's a component and system that's called a hot zone. And that's where basically electrical power that's input into the furnace gets translated into heat. And there are some very important things that happen with the hot zone design and optimization in terms of getting the power to the places where you want for thermal uniformity at the crystal growth interface, but also you want to be able to provide adequate insulation such that the whole overall process is efficient. And lastly, we help companies who are installing equipment, and that's including equipment made by others, because there are many opportunities to do that, particularly with the reshoring of many large-scale solar projects that are happening today as part of the IRA and some other government support. There are a lot of projects where we can help with installing equipment, commissioning equipment, and going beyond that as well, including facility design. I'll just touch quickly on what we're doing in our battery area. Again,
30-second warning, Paul.
I'm sorry?
30-second warning on timing.
Yep. Just really quick highlights on what we're doing in battery. I'll just touch it quickly. A lot of project examples here. We won't go through anything on this slide. The whole point of this slide is just to show you the spectrum of where we work within the battery area and in the various ways that we work on various functions and other projects within each area. Thank you.
Thank you so much. That was great. And we'll open the floor to questions. If anybody has any, just raise your virtual hand and Paul will be happy to answer whatever question you have. Actually, I see a comment from Javier that yeah, he
Brian.
wants to get.
Yeah, I can
okay.
elaborate. Ensign runs a variety of programs, and one is called Maker. And the purpose of Maker is to help the students in our programs or the very early stage companies get to develop that first prototype. And so we partner with like maker studios and labs to get some of that done.
Yeah.
So yeah, Paul, I'll send you an email here in a second. If you can just type your email in the box here, I'll send you an email so we can chat after.
Yeah, I did include my contact information earlier, but I'll put it in one more time, or if yours is in there, I'll contact you directly as well. Thank you.
Okay.
Great, we have time for another question if anybody has any. Paul, not sure if you covered this, just what are you looking for? Like, what are you looking to get out of this presentation?
Yeah. We're looking for to work with companies and portfolio companies in the case of investors that have particularly challenging engineering projects or automation projects, companies that are trying to scale up their technology, particularly deep tech companies that are trying to move from either prototype to alpha or alpha to beta and then into mass production. And there's a lot of things I didn't talk about regarding what we do at high volume production, but that's for another time.
Great. So that's actually all the time we have.
Yep.
But thank you so much, Paul. It was great.
Yeah, thank you.
And I just redropped your contact info in the chat if anybody wants to reach out to you. So again, thank you so much. And we'll move on to our final presentation of the day, which is Lion Energy.
Hey there, everyone. Let me bring my slides up and let me know if you can see my screen as well as me as well. Okay. Okay, can you see the presentation?
Yes.
All right, so hi everyone. I am Kelsey Mitchell, and it looks like my video isn't actually working, but that's all right. We'll roll with it. I am the project manager here at Lion Energy, and we are a renewable energy company helping individuals and organizations become energy independent by providing safe, silent, and renewable power. We are located in American Fork, Utah, as well as have a facility in Atlanta, Georgia. Just to highlight a little bit of our technical expertise within our employees here from previous jobs, we've got experience at Valeo, Tesla, Rolls-Royce, and Solarc, to name a few, where our projects ranged from, EVs to solar systems to aircraft engines and so forth. So we bring a lot of experience to the table. Lion's been around for about 10 years, and we've gone roughly from 5 engineers on our team to about 50, and then our company is about 200 people total. So we've grown over the last couple of years tremendously, and we'll give thanks to the solid architecture and systematic structure we've got within the company to build and expand. We've got multiple groups within the company, from emerging markets, technology, marketing, and sales. And then I've highlighted a little bit of the engineering disciplines we've got in-house. So with this allows us to follow a PLM approach to developing new components. We do have the capability to test a lot of these on the spot in our validation space, from our smaller batteries to larger energy storage. Another big perk of our in-house capability is that we develop our web app and mobile app internally. So we have a lot of power at our fingertips, as well as a very cyber secure and private data as well, which helps us in the long run. All right, so the need for energy storage. This isn't necessarily a new thing, but we've obviously been on a journey to move away from fossil fuels and to clean energy for the last few decades. With this transition, though, to use solar power comes the responsibility to actually store it and use it in an efficient and effective manner. Some of the existing challenges that the industry is facing is generally around the barriers of high costs of implementation, technical challenges with the existing grid infrastructure, and the lack of incentives. The cost of lithium is still very high. And then one of the biggest problems we see with creating efficient energy storage systems is really the circularity of them, ensuring that the batteries are disposed of properly as well as safely. So something that Lion adds value here in this space is we use lithium iron batteries, which last longer than other chemistries. The chemistry is very safe. It has a lower cost per kilowatt hour, longer life expectancy. We also have direct ties to our sister company, which is ABF, and hence we can directly ensure we're designing for reusability and recyclability. Another thing we really focus on and anticipate is kind of the start to end of the full process and ensuring that we can recycle appropriately. So by taking over this kind of start to finish process, we do have full control, and therefore we can ensure we're a leader in this industry. And kind of the final vision of our company is obviously that one day every building will have its own energy storage as part of its, you know, housing architecture as well as industrial architecture. All right, so to highlight just a little bit of our core products here, we have our solutions are from our smaller handheld batteries to solar panels and converters. We do want to showcase, you know, our web and mobile app, which I've taken some screenshots here just to show you the usability. A lot of what we try to hone in on is customer experience, right? How easy can we make it for our customer to use their energy storage system at home, monitor what's going on, and be able to understand what their system is doing and how it's actually helping them save money. From there, we've got some of our larger commercial and industrial and grid support applications. In the bottom left, we have our Sanctuary, our cabinet and container, which I'll highlight a little in the next slide. And then as you can see in the middle, our web app and mobile app kind of show some of those interfaces from flow graphs to peak shaving and power factor correction. So there's full visibility of these from the user side. All right, so to dive into a little bit more about our energy storage systems, as I mentioned, the Sanctuary, our cabinet and container are some of our larger systems. And to throw some numbers on here just to show you the range of energy and power that we have. You know, we have an energy capacity of our smaller cabinets from 13.5 kilowatt hours. Our cabinet itself from 30 kilowatt all the way up to 90 kilowatt, and then energy capacity of our largest container from 3.4 all the way up to 5 megawatt hours. So these systems are tailored to the requirements of the customer and all key stakeholders. So we are very agile in our ability to meet the needs of different site requirements. The middle picture does show one of our installs in Tennessee, which is currently providing backup power to a school. The system contains gas detection, heat detection, and smoke detection as well. So it's a very safe system. Some of these applications provide just backup power. Others provide backup power integrated with solar panels. So there is a diverse kind of application we see here, as well as some of our systems have different configurations between battery and inverter from 1 to 3 all the way up to 4 to 12 configuration for our smaller Sanctuary system. Just to highlight some of the more sophisticated functionality within the system, I've got the yellow box here showing load management, limit grid consumption, obviously helping reduce energy demands, the brain of the system as the energy management system itself. We do have control of that. So essentially finding ways to reduce power consumption where we can, hence lowering the bill for a lot of these customers. All right, wanted to just hone in on one of our larger energy storage systems, the Sanctuary, again, just to show the usability and customer experience with the product. So the graphs in the middle essentially just highlight that we can show the full consumption being used by the house, what it's pulling from the grid or giving back to the grid. what the solar panels are using, how much energy, as well as the state of charge. And this system is set to update every 5 minutes. So not only are we creating this database of the history of when are we pulling the most from the grid, but future applications such as machine learning, how can we actually optimize this and make it an efficient system that runs itself moving forward? So that is something that we're excited about. And a lot of these systems, again, the mobile and the web app user interface really creates for a great customer experience. Did want to highlight our American battery factory. So those cells are used in some of our battery rack modules. So some of our main R&D components highlighted on the right here that we are building in-house are battery rack module, our energy management systems, our battery management systems, and then we are looking to come up with some sort of collaboration with third-party companies to see where we can step foot into the green hydrogen space. What can our batteries do that our Lion Energy provided and actually help contribute to that hydrogen technology movement? And finally, what we are seeking, so we are seeking additional partnerships, commercial and or government, to expand our footprint and really see where we can step foot into space that we have not touched yet, as well as just work with those partnerships to tailor our technology. As I mentioned, we are able to adjust the requirements and the system architecture very well to cater to our customers, and that's something that gives us a lot of value to the industry. So that is all I have, and I did include our emails on this slide if there are further questions, and our Chief Technology Officer, Terry, is on the line as well to help answer additional questions.
Great. Thank you so much, Kelsey. So with that, we'll open the floor to questions. If anybody has a question, please raise your hand, ask away. This is going to be your last opportunity to ask a question. So be sure to get one in for Lion Energy. I guess I could start. I mean, Kelsey, just very generally, broadly, any points that you wanted to make that maybe haven't been included in the presentation that maybe you could expand on, or you'd like to expand on?
Yeah, Terry, would you like to add anything from a business perspective or larger company mission, perhaps?
Yeah, sure. There is two main objectives that we want to achieve with engineering development. One is really having a US-made product. So that's very important that our ABF, our sister company, ABF, is going to make cells in the US, and we are going to use those cells to build a battery pack. And with a battery management system that designed and produced by us here locally, and meaning that's open to made in USA product. The other point I want to make is that in the technology that we develop, we want to be sure that we will have a reusability and a serviceability of our product for several reasons, but one of them also is the fact that we want to be able to dispose those cells when they are not good anymore, and to do so, we want to be sure that we will have a recycling process that will be seamless, meaning that those cells will have been able to be recycled without the destruction of the rest of the system, meaning that the rest of the system will be reusable for other battery packs. So that's the two main points I wanted to make in terms of what we try to achieve. We also develop some electronic board internally, and that's what that give us the capability of adjusting some function and be able to even solve some challenges on a company partner that will have some specific challenges. We have full control of all the system up to the BMS and down to the full application. So that's what we bring to the table.
Great. So we do have time for a question if anybody has one. This is your last chance if you want to ask a question. So I'll give that a brief moment. If anybody has trying to formulate a question in their head, who wants to get one out. And if not, maybe some people are taking more time to put a question together. But if there are no questions right now, of course, you could reach out to the Lion Energy team at the emails that appear on the screen. So please feel free to reach out to them and get in touch if you have anything you want to discuss further or ask them. But with that, that was the last presentation of the event. So thank you again so much, Lion Energy team. We very much appreciate it. It was a very good presentation. I just think people were maybe a bit tired toward the end of the event. It's been a pretty long event.
Thank you, Ryan.
So, sure. Thank you. So with that, that concludes our Energy and Clean Tech Showcase. Thank you so much to all the companies, gave amazing presentations. Thanks to everybody who stuck it out for the entire event. One of our longer events in a long time. And of course, thank you to the panelists for taking the time to sit in and watch these great companies pitch their innovative solutions and ask thought-provoking questions. So in terms of a recording, we will be sending a recording of this event likely later this week, possibly early next week, but more likely later this week. So you'll be able to view it and rewatch some of these presentations. And if you want to get in touch with any of the companies, please reach out to me or the companies themselves as they put out the contact info. So again, thank you so much. Very much appreciate all of your times and all the companies' great presentations. And we'll see you at our next showcase, which is in about a month, Industry 4.0 on April 25th. So thanks again. Be well, everybody. Have a good rest of your day.